You might think you know the night sky pretty well. Look up on any clear evening, and there they are, the same patterns of light humanity has gazed upon for thousands of years. The stars seem so predictable, so neatly arranged, like a vast ceiling painted with familiar shapes. But what if everything about the way you see those patterns is built on a gentle illusion? What if that simple, friendly constellation you can trace with your finger is actually something so enormous and scattered that it challenges every assumption about what near and far really mean? The sky has been quietly fooling us all along, not through deception, but through the strange way distance and perspective work on scales our minds weren't built to handle. Scientists themselves have been surprised again and again by how much complexity hides behind the simplest stellar patterns. Reality, it turns out, is rarely as tidy as it first appears. In this video, we'll explore just how big the Leo constellation really is, peeling back the layers of what seems obvious to discover something far more vast and mysterious than you might expect. If you like these videos, I would appreciate if you clicked like or subscribed, as it's important for the channel, and it helps others find it too, just like you did. Thank you. Now, let's get started. Something as simple as spotting a lion in the sky turns out to hold secrets that stretch across unimaginable distances. When we look up on a clear night, our eyes naturally search for patterns, shapes that feel familiar and comforting. We see a constellation like Leo, and it appears manageable, friendly, even like a drawing someone sketched across the darkness. But the universe has a way of hiding its true scale from us. What looks like a neat little picture is actually something far more vast than our minds are comfortable grasping. Each point of light in that lion shape exists at a completely different distance from Earth, scattered through space like ships on a dark ocean at various distances from shore. Take Regulus, the brightest star in Leo, often called the heart of the lion. This brilliant white-blue point sits about 79 light-years away from us. The light entering your eyes tonight began its journey from that star almost 8 decades ago. Back then, television was still a new invention, computers filled entire rooms, and most of the technology we rely on today existed only in the realm of imagination. Yet Regulus isn't even the most distant star in Leo's pattern. Another prominent star, marking the lion's tail, sits only 36 light-years away, less than half the distance. Just by moving your gaze slightly across this constellation, you're jumping through tens of light-years of empty space. It's like looking at lighthouses that appear side by side, that actually stand on completely different coastlines. Then there's another golden star in Leo, which turns out to be 2 stars orbiting each other, positioned roughly 130 light-years from Earth. Within this single constellation, we're already spanning nearly 100 light-years from front to back, and that's counting just 3 stars. The fainter points of light that fill out the rest of the lion's shape push those boundaries even further. Some stars associated with Leo lie more than 300 light-years away. Others sit relatively close, cosmically speaking, at just a few dozen light-years. The familiar shape we recognize isn't a group of stars traveling together through space. It's more like a cosmic coincidence, a moment where our particular viewpoint from Earth happens to line up these distant suns into something our pattern-seeking brains can recognize. Imagine walking down a long corridor filled with glowing lights suspended at different distances. From one specific spot, those lights align to create what looks like a face or an animal. Take just a few steps to either side, and the image completely falls apart. That's Leo in reality, a perspective drawing created entirely by our position within the Milky Way galaxy. When astronomers measure how wide Leo appears across the sky, they use degrees. The full moon spans about half a degree from our perspective. Leo stretches roughly 50 degrees from one end to the other, which means it covers the width of about 100 full moons placed side by side. If you hold your fist at arm's length, it covers approximately 10 degrees of sky. Leo spans about 5 fists from head to tail, but that's just the flat, 2-dimensional answer we get from looking up. The 3-dimensional reality quietly expands into something almost incomprehensible. If we drew an invisible box around all the major stars that create Leo's pattern, that container would need to be hundreds of light years deep. The closest stars sit around 30 light years away, while the farthest ones are positioned near 300 light years out. At an average distance of about 150 light years, Leo's 50-degree span across the sky translates to a physical width of more than 130 light years from side to side. If we could somehow step outside our galaxy and look back at Leo as a real three-dimensional object, it wouldn't resemble a flat drawing of a lion at all. Instead, it would appear as a vast, scattered cloud of stars stretched wider than most human minds can comfortably picture. Our entire solar system, from the Sun all the way past Pluto, and the distant icy objects of the outer regions, measures only a couple of light days across. Even including the farthest reaches of the comet cloud that surrounds our system, we're talking about maybe 1 or 2 light years at most. Leo, in both depth and width, spans more than 100 times that distance. Yet in our sky, it fits comfortably between 2 outstretched hands. There's something both humbling and oddly comforting about this realization. The universe doesn't rush these moments of understanding. It allows them to settle slowly into our consciousness, like dust motes drifting through afternoon sunlight. These enormous distances that Leo encompasses still represent just a tiny patch within our galaxy. The Milky Way itself stretches about 100,000 light years from edge to edge, making even this vast constellation just a small neighborhood within a much larger cosmic city. The trick our eyes play on us, flattening everything into what appears to be a single dome overhead, isn't a flaw in human vision. We evolved to judge distances between trees, animals, and other people, not the vast separations between distant suns. So when we gaze at Leo, we're seeing a pattern that exists only from our specific vantage point in space and time. Some objects associated with Leo aren't even stars within our galaxy. Through telescopes, certain parts of the constellation reveal faint, fuzzy patches of light. These distant smudges represent in entire galaxies, island universes containing billions of their own stars, sitting millions of light years beyond even the farthest stars in Leo's pattern. This layering of distances, from relatively nearby stars to impossibly distant galaxies, all appearing in the same small patch of sky, speaks to something profound about perspective and scale. We live in a universe where the familiar and the unimaginably vast occupy the same view, where a simple shape traced by ancient starlight contains depths that stretch the very limits of human comprehension. The next time you spot Leo rising in the evening sky, perhaps you'll remember that this friendly lion shape is actually a vast three-dimensional sculpture made of distant suns, each with its own story, its own journey through space and time. The pattern we see is fleeting on cosmic scales, slowly changing as these stars move through the galaxy at different speeds and in different directions. In a few 100,000 years, the constellation will look completely different. The lion will fade into new patterns, new stories written across the darkness. But for now, in this brief moment of cosmic time, we can look up and see these distant lights arranged just so, creating a shape that connects us to ancient myths, to the human need to find meaning and beauty in the vast night sky above. Looking up at the constellation Leo reveals something far more complex than most people realize. When your eyes trace that familiar backward question mark in the sky, you're actually seeing stars scattered across hundreds of light years of space. Some of those points of light are relatively close neighbors, maybe 50 light years away. Others sit much farther out, perhaps 200 light years distant. Yet from our perspective on Earth, they all appear to line up in a neat, flat pattern. This creates an interesting illusion. The night sky acts like a giant projection screen, flattening three-dimensional space into a two-dimensional view. It's similar to looking at a city skyline, where a nearby streetlight, a building 10 blocks away, and mountains on the horizon all seem to exist on the same flat backdrop. The stars we connect to form Leo's shape have no real relationship to each other in space. They just happen to lie along the same line of sight from our solar system. But there's something even more remarkable hiding behind Leo's stars. Scattered throughout that region of sky are objects that aren't stars at all. They're entire galaxies, island universes containing billions of stars each. The Leo triplet, for instance, consists of 3 spiral galaxies sitting about 35 million light-years away. When you gaze at Leo, you're not just looking at nearby stellar neighbors, you're peering through our local cosmic neighborhood and out into the vast universe beyond. Think of it this way. You step into your backyard and look toward the horizon. In one glance, you might see your neighbor's fence, a water tower across town, hills in the distance, and clouds floating much higher up. Each exists at a completely different distance. Yet they all occupy the same narrow slice of your view. The night sky works exactly the same way, layering near and far into a single, panoramic scene. This layering reveals something profound about how we experience the universe. The sky doesn't organize objects by distance. It arranges them by direction. A star that's practically next door, astronomically speaking, might sit right next to the apparent position of a galaxy so distant that its light began traveling toward us before life even existed on Earth. Both occupy the same tiny patch of darkness when viewed from here. Ancient stargazers understood this concept intuitively, even without telescopes or modern astronomy. They recognized that the sky held mysteries beyond what they could directly observe. When they looked at Leo, they saw not just a pattern of lights, but a gateway to something larger and more mysterious. Different cultures developed their own stories and meanings for this celestial lion, but they all sensed its deeper significance. The Greeks wove Leo into their mythology as the Nemean lion, the beast with impenetrable skin that Hercules defeated in his first labor. Zeus supposedly placed the lion among the stars to commemorate both the creature's strength and the hero's victory. This story transforms Leo from a simple dot-to-dot drawing into something with weight and presence, a memorial written across the night sky. But Greek storytellers weren't the first to see a lion in this star pattern. Babylonian astronomers identified the same celestial creature thousands of years earlier, calling it the Great Lion and connecting it to their seasonal calendars and religious observances. Egyptian skywatchers also recognized this stellar lion, timing important festivals to its annual appearances in their night sky. What's fascinating is how consistent this interpretation remained across different cultures and centuries. Despite having no contact with each other, people separated by vast distances and long spans of time looked at the same arrangement of stars and saw the same basic shape. This suggests something fundamental about human pattern recognition, the way our minds naturally organize random points of light into familiar forms. The star we call Regulus anchors Leo's pattern, marking the lion's heart with steady blue-white light. Regulus sits about 79 light-years away, making it relatively close in cosmic terms. It's actually a complex system of 4 stars bound together by gravity. Though they appear as a single point to our eyes, this star spins incredibly fast, completing one rotation every 15 hours or so. If it spun much faster, centrifugal force would tear it apart completely. Moving outward from Regulus, the other bright stars of Leo tell their own stories. Some are young, hot, massive stars that burn through their nuclear fuel quickly and dramatically. Others are older, more mature stars like our Sun, quietly fusing hydrogen in their cores and shining steadily for billions of years. A few represent stars in their final phases, having exhausted their core fuel and expanded into red giants before eventually cooling into white dwarf remnants. Each of these stars follows its own orbital path around the center of our galaxy. They move at different speeds and in slightly different directions, like cars on a cosmic highway system. Over very long periods of time, these individual motions gradually change the apparent shape of Leo as seen from Earth. The constellation we recognize today looked different 50,000 years ago, and it will look different again 50,000 years in the future. This slow transformation touches on something profound about permanence and change in the universe. When we look up at Leo, we see what appears to be a fixed, eternal pattern. The same stars occupy the same relative positions night after night, season after season, year after year. Ancient observers saw essentially the same lion shape that we see today. Yet underneath this apparent stability, everything is in constant motion. The stars themselves are aging and evolving. The most massive ones will eventually explode as supernovae, briefly outshining entire galaxies before fading forever. The longer-lived stars will continue their slow dance around the galactic center, gradually drifting apart until the familiar lion pattern dissolves into unrecognizable scattered points. Even our solar system participates in this cosmic choreography, carrying Earth and its observers along on our own quarter-billion-year orbit around the Milky Way's heart. Standing under a dark sky and contemplating Leo connects us to this vast slow-motion symphony of stellar movement. In a single glance, we're witnessing light that left distant stars decades or centuries ago, mixed with the glow from galaxies whose photons have been traveling toward us since before our species existed. We're seeing the present arrangement of a pattern that has been slowly shifting for millions of years and will continue evolving long after our civilization has been forgotten. The Nile River floods brought ancient Egyptians more than just water and fertile soil. They brought a celestial calendar written in starlight. When certain stars appeared in their sky, the people knew their land would soon be reborn. This wasn't just observation, it was survival wrapped in mythology. Halfway across the world, Chinese astronomers were mapping the same patch of sky, but where Egyptians saw connections to their flooding river, the Chinese saw imperial power, cosmic order, the very structure of heaven itself. They divided their sky into regions, each one carrying political and spiritual weight that reached from the emperor's palace to the edges of the known world. This same collection of distant suns has been a lion, a dragon, a sickle, a question mark drawn in light. Every culture that looked up created something different from identical raw materials. The stars themselves haven't moved much in thousands of years, but the stories, the meanings, the shapes we impose on them, those shift like shadows. What we call Leo exists more in human imagination than in physical space. The lion lives in our star charts, our ancient myths, our modern apps that point toward patches of sky. We're looking at light separated by decades of distance, scattered across a volume of space so vast that the very idea of a pattern becomes almost absurd. Yet there it is, night after night, our celestial cat. Regulus anchors the whole arrangement. Ancient Romans called it the Little King, and the name carries weight. This star sits close to the ecliptic, that invisible highway where planets and moons travel across our sky. Sometimes these wandering objects pass directly in front of Regulus, hiding it briefly, making it seem like this star somehow participates in the dance of the solar system, rather than just watching from the sidelines. Through a telescope, Regulus reveals its secrets. What looks like a single brilliant point becomes a complex family. At least 4 stars are bound together here, held by gravity in an intricate gravitational waltz. The main star, the bright one you can see without any help, spins so fast it's actually flattened at its poles. It's hurling material into space, burning through its fuel at a tremendous rate. Living fast and bright, in a way our steady sun never could. Move your telescope slightly, and you'll find Algeba, the golden star that helps form the sickle shape. With just a modest instrument, this single point of light splits into 2 stars orbiting each other in a slow, elegant dance that takes decades to complete. Their combined light creates that warm golden color that feels almost gentle compared to the harsh white glare of Regulus. Hidden partnerships like this exist throughout the constellation, small families of stars masquerading as single points of light. At the tail end of our lion sits the nebula, younger than most of its companions and surrounded by a disk of dust. Somewhere in that cosmic debris, planets might be forming right now. Particles are slowly clumping together over millions of years, building worlds grain by grain. Perhaps someday something will evolve on one of those distant worlds and look up at its own night sky, wondering about the patterns it sees there. When you start noticing these details, Leo stops being a simple connect-the-dots picture. It becomes a neighborhood, a loose community of stars that just happen to line up from our particular viewpoint in the galaxy. This is where meeting Leo becomes more than pattern recognition. It becomes an introduction to the depth hiding behind apparent simplicity. If you could travel between these stars the way you walk between rooms, the journey would humble you. Regulus sits 79 light-years away. Even traveling at the ultimate speed limit of the universe, it would take you nearly 8 decades to reach it. From there, swing over to Denebula, and you're looking at another 40-some years of travel time. A simple tour of the Lion's main features would consume centuries, and all the while, the galaxy would be slowly rotating around you, stars shifting in ways too subtle to notice on human timescales. From Earth, all this vast three-dimensional landscape collapses into a flat picture. That collapse is part of what makes Constellation so powerful and so strange. They let us hold something enormous in a human-sized mental frame. You don't need to think about stellar evolution or interstellar distances to enjoy the simple pleasure of finding the lion in the sky. You just look up, connect some dots, and there's your cosmic companion for the evening. In the Northern Hemisphere, Leo marks the changing seasons with reliable precision. It rises in the east during late winter evenings, climbs high overhead by early spring, then begins its slide toward the western horizon as summer approaches. For thousands of years, people used these rising and setting patterns as natural calendars. The lion's return wasn't just beautiful, it was practical information. Farmers knew when planting seasons were near. Sailors could anticipate weather changes. Communities scheduled festivals and rituals around these stellar rhythms. Modern astronomy has given Leo official boundaries, turning it from a mythological figure into a postal code for the sky. The International Astronomical Union drew precise borders in the 20th century, creating a specific region of the celestial sphere. Now, when astronomers discover a new comet or asteroid, they can say it's in Leo even if it has nothing to do with the stars that form the lion shape. This practical Leo exists alongside the mythical one, two different ways of organizing the same patch of sky. The version of Leo you carry in your mind probably depends on how you first met it. Maybe it's the clean outline from a star chart, or the heroic myth of celestial battles. Perhaps it's a seasonal marker that tells you spring has arrived, or just a handful of bright points connected to a personal memory, a camping trip, a late-night conversation, a moment when you happen to look up and notice something beautiful in the darkness. Constellations often become anchors for human memories. The sky serves as a backdrop for our earthbound moments, and the patterns we recognize become linked to specific times and places in our lives. In this way, Leo can feel deeply personal. Even though it's made of stars so distant, they'll never know we exist. Step outside our cosmic neighborhood, though, and the lion vanishes. From a few hundred light-years away, the familiar shape would stretch and distort beyond recognition. Regulus might drift away from the sickle. Denebula could slide out of alignment with the body. The careful pattern we know would fall apart, replaced by some entirely different arrangement that makes sense from that new viewpoint, but would be meaningless from here. Our lion belongs to this specific location in the galaxy, this particular moment in cosmic history. The stars that form Leo are moving, following their own vast orbits around the galactic center. Given enough time, tens of thousands of years, the shape will change. The question mark of the head will open up, the line of the body will bend and twist. The tail will wander off in a new direction. Future sky watchers, if there are any, might not see a lion at all. They'll create their own patterns and tell their own stories about the same collection of distant suns. There's something quietly comforting in knowing that while Leo is temporary on cosmic scales, it's steady enough on human ones. You can step outside tonight, next year, or a decade from now, and find the same familiar pattern waiting in the darkness. It's a slow-moving companion that keeps pace with our brief lives while participating in changes so gradual they might as well be eternal from our perspective. The way our minds work with distant objects creates something remarkable when we look up at night. Your brain takes everything beyond a certain distance, groups it all together as simply far away. This happens because your eyes can only judge depth when things are relatively close. using the tiny differences between what each eye sees. Once something reaches the distance of the moon, that depth perception just stops working entirely. So the entire night sky gets flattened into what feels like a painted ceiling, a smooth dome where everything seems to exist on the same surface. The stars become like dots of light on black paper, rather than massive nuclear furnaces, separated by distances so vast they defy everyday understanding. This flattening effect explains why Leo the lion feels manageable, contained, almost cozy. When you trace its outline with your eyes, you're not thinking about the fact that Regulus, its brightest star, sits about 79 light-years away from us. You're certainly not considering that other stars in the pattern lie at completely different distances, some closer, some much farther away. Your mind naturally wants to fit everything into scales it can handle. You move through a world of steps, rooms, city blocks. Even the largest things you regularly encounter, like mountain ranges or ocean horizons, still exist within boundaries your brain can process. So when Leo stretches across a portion of sky, your mind translates this into something like a large shape up there, big in the way a cloud might be big, not big in the way a region of space hundreds of light years across actually is. This mental shortcut isn't a flaw in thinking, it's actually a kind of protection. The universe operates on scales so enormous that holding them in constant awareness would be overwhelming. Your brain wisely scales things down to something livable, something that fits into your daily experience of being human. The sky also refuses to follow the normal rules about distance that work so well on Earth. Usually, things farther away look smaller. A distant mountain appears tiny compared to a nearby tree, but stars don't follow this pattern at all. Some of the brightest stars you see are incredibly far away, while some dim ones are relatively close neighbors. Brightness depends more on how much energy a star produces than on its distance from you. This creates a gentle equality among the points of light above. A star dozens of light years away and a galaxy millions of light years away can both appear as similar tiny specks. Everything becomes democratized into glimmers, leaving your imagination to fill in the rest. For most of human history, people had no concept of light years or galaxies. The sky was simply a realm above, beyond birds and clouds, but not necessarily extending outward through unimaginable depths of space. In that context, seeing constellations as drawings on a celestial ceiling made perfect sense. They were pictures placed there by cosmic forces, meant to be read like stories written in light. Even now, with all our scientific knowledge, that ancient perspective still influences how you first experience the night sky. You don't automatically think about specific distances when you look up. You think, there's a star, there's another one, there's a pattern I recognize. Your immediate experience remains beautifully simple. Consider how a city skyline looks from far away at night. You see clusters of lights, some from tall buildings nearby, some from smaller structures farther away, maybe even from towns beyond the city itself. From your distant viewpoint, all those lights blend into a single shimmering outline. You might trace shapes in them, give them names in your mind. That's remarkably similar to what happens with constellations. The key difference is that with the night sky, you can never drive closer to see the layers separate. You're locked into one viewpoint, one place in space, and the patterns you see are tied specifically to that position. This fixed perspective makes constellations feel stable, self-contained, like actual objects rather than chance arrangements. The way stars move across the sky reinforces this feeling. Over the course of the night, they rise in the east, set in the west, turning slowly around the celestial pole. They move together, as if attached to the same enormous wheel. Leo rises as a group, crosses the sky as a group, sets as a group, sets as a group. This shared motion strengthens the impression that it's one coherent thing. In reality, each star in Leo follows its own individual path through space, orbiting the center of our galaxy at its own speed and angle. But these motions happen so slowly, compared to human lifetimes, that the patterns remain essentially frozen from your perspective. What you see tonight is virtually identical to what people saw thousands of years ago. This stability across human generations adds another layer to why constellations feel small and manageable. They become landmarks in time as well as space, seasonal signposts that return predictably year after year. Leo appears in spring skies like an old friend keeping an appointment. This reliability makes the vast cosmos feel more like a neighborhood, a place with familiar markers and rhythms. There's something profound about how your small physical presence in the universe shapes what feels possible to comprehend. You experience the world through a body measured in feet and inches, moving through spaces measured in miles and hours. When the night sky presents itself to your senses, your mind naturally tries to incorporate it into that same comfortable scale. The darkness between stars contributes to this effect too. When you look up for long periods, that darkness doesn't feel empty. It takes on a presence of its own, a soft depth that seems to connect the points of light into a unified whole. The black spaces become part of the pattern, negative space that gives meaning to the positive space of the stars themselves. This transformation of cosmic distances into manageable patterns represents one of the most fundamental ways humans relate to the universe. We take something genuinely incomprehensible and find ways to make it comprehensible, not by finding bridges between its reality and ours. The night sky presents itself to us as a kind of cosmic theater, where patterns of light seem to drift slowly overhead in perfect unison. What we're actually witnessing is our own planet rotating beneath us, carrying us through space at over 1,000 miles per hour. Yet from our perspective, it's the stars that appear to move, sweeping across the darkness in their ancient, predictable dance. This creates an interesting illusion of intimacy with the cosmos. When you spot Leo the lion stretched across the spring sky, it feels manageable, contained, almost friendly. The constellation seems to fit neatly within your field of view, like a picture hanging on the vast wall of night. Your brain processes it as something you can grasp, both literally and figuratively. Part of this sense of smallness comes from how we first encounter these stellar patterns. Most people learn constellations from books, apps, or star charts, where Leo appears as a tidy outline that fits comfortably on a page. Your mind forms a mental snapshot of something compact and organized. When you step outside and find the actual constellation, that pocket-sized mental image travels with you. It's remarkably similar to studying geography from an atlas. A country looks so manageable when reduced to colored shapes on paper. You can trace its borders with your finger, measure distances with a ruler. But if you actually tried to walk across that same country, day after day, mile after mile, its true scale would slowly reveal itself. The sky works the same way. The longer you spend beneath it, the more it transforms from a simple diagram into something far more complex. Consider what would happen if you could drift away from Earth, not in some dramatic rocket launch, but slowly, gently, like a balloon released into space. As you rise above the atmosphere, past the moon's orbit, beyond the outer planets, the familiar star patterns would hold together at first. Leo would still look like a lion, but venture far enough into interstellar space, and something fascinating begins to happen. The stars that seemed so perfectly arranged start to drift apart. Regulus, the bright heart of the lion, shifts position relative to its neighbors. The graceful curve of the lion's mane begins to distort. From a distant enough vantage point, there would be no lion at all, just a handful of unrelated stars scattered across different regions of the galaxy. This reveals something profound about perspective and meaning. The smallness you perceive when looking at Leo isn't actually a property of those distant suns. It's a product of your specific location in space, your particular viewpoint in this vast cosmic arrangement. There's something both humbling and empowering about that realization. Your tiny place in the universe is enough to create pattern and significance in something incomprehensibly large. You're like a conductor who can organize the symphony of starlight into recognizable melodies, simply by standing in the right spot and knowing how to look. But perspective works both ways. Sometimes when you really contemplate the distances involved, when you try to wrap your mind around the fact that Leo's stars are dozens or hundreds of light years away, the feeling of smallness shifts. Suddenly you're the small thing, and the constellation becomes enormous, almost overwhelming in its scale. Which perception is correct? The answer depends entirely on where you choose to focus your attention. When you concentrate on the pattern itself, on the simple act of recognition, Leo feels approachable, even cozy. When you think about the physics behind it, the nuclear furnaces burning across its gulf of space, it expands into something vast and humbling. Your mind can slip between these two scales without warning. One moment you're casually tracing a lion's outline, the next you're confronting the reality of ancient starlight that began its journey before human civilization existed. This ability to zoom in and out mentally, to hold multiple scales simultaneously, might be uniquely human. Other creatures navigate by stars, follow celestial cues, respond to cosmic rhythms. But this particular type of wonder, this capacity to ask how big something really is, and then imagine layers of distance and time behind a simple pattern of light, seems to be something we do quite well. Familiarity also plays a crucial role in how constellations feel to us. Anything you encounter regularly begins to shrink emotionally, if not physically. A mountain that dominates your daily commute eventually becomes part of the background scenery. You stop really seeing it, stop feeling its massive presence. The same thing happens with the night sky. If you grow up watching Leo rise every spring, year after year, it transforms from a cosmic mystery into a seasonal friend. You expect it, recognize it, take comfort in its reliability. Things that feel known tend to feel smaller, more manageable. Every so often, though, something breaks through that comfortable familiarity. A particularly clear night far from city lights, a moment when you have time to really look up without distraction. In these instances, the sky can suddenly feel vast again, as if you're seeing it for the first time. The familiar patterns stop looking like simple drawings and start feeling like windows into something much deeper. Even the word constellation shapes how we think about these stellar arrangements. It comes from Latin roots meaning a set of stars, a collection, a grouping. The term doesn't imply a single object or creature. It suggests an assembly, a gathering of separate elements. But when we say Leo, it sounds like the name of a being, something unified and whole. That sense of wholeness makes the constellation feel compact, self-contained. If we instead described it as a loose collection of unrelated stars at various distances, all happening to lie in the same direction from our perspective, it would feel much larger, much messier, much harder to mentally contain. So we stick with the simple names, the familiar shapes, the ancient stories. In doing so, we make something truly vast feel small enough to live with comfortably. Time adds another layer to this puzzle. Stars change, but incredibly slowly. Constellations evolve even more gradually. Over a human lifetime, these patterns remain essentially frozen. You can look at Leo as a child, and again decades later as an adult, and it will appear identical. This stability makes the constellation feel solid, permanent, like a reliable feature of the world. Things that don't change have a way of fading into the background of our attention. A steady clock becomes invisible until it stops ticking. A humming fan disappears from awareness until the power goes out. The sky, in its patient constancy, can become like that background hum. Always there, always the same, easy to take for granted. So Leo feels small, partly because it's so dependably steady. But zoom out far enough in time, and even that steadiness dissolves. Stars drift through space over millions of years. The galaxy rotates. Stellar patterns dissolve and reform in an endless, slow dance. The lion you know is just a temporary arrangement in a cosmic ballet that's been unfolding for billions of years. You can't perceive this change directly. It happens at a pace that makes all of human history look like a brief moment, but it's there, constant and inexorable. When you hold all these factors together, the apparent dome of the sky, the limits of human vision, the habits of mind, the stories we tell, the scale of our bodies, and the patience of cosmic time, You begin to understand why constellations feel the way they do. They feel small because they meet us where we are. They don't present themselves as vast clouds of nuclear fire scattered across interstellar distances. Instead, they offer simple patterns we can recognize, remember, and return to night after night. They provide a way to connect with the universe without being overwhelmed by its true scale. Perhaps this isn't a limitation at all, but rather a kind of gift. An invitation to begin with something manageable, a shape, a name, a story, and then, if we choose, to slowly discover the profound depths that lie behind that comfortable simplicity. When you glance up at the night sky, your eyes naturally group stars together, like old friends gather. And signed, your eyes naturally group stars together, like old friends gather. And tine, that the peas is, that when two four pin, that the tined, that the peas peer. But here's something that might shift how you see those twinkling dots. They're not actually close to each other at all. Take the constellation Leo, that proud lion stretched across spring skies. Those stars that seem to outline his mane, his body, his tail. They're scattered across distances so vast that calling them neighbors would be like saying two people are neighbors when one lives in New York and another lives in Tokyo. Only the distances are much, much larger than that. Your brain is incredibly good at finding patterns. It's one of the things that makes us human. You see faces in clouds, animals in rock formations, meaningful shapes everywhere you look. The night sky becomes another canvas for this pattern-seeking mind of yours. When you see Leo's stars, your brain connects them into something coherent, something that makes sense. But in reality, these stars are like strangers passing each other on a cosmic highway. Some of them are 36 light-years from Earth, others are 79 light-years away. Still others stretch out beyond 100 light-years into deep space. The distances between individual stars in Leo are so enormous that our entire solar system would fit in the space between them, like a marble rolling around inside a cathedral. Light travels faster than anything else we know about. It crosses the distance from Earth to the Moon in just over a second. But the light reaching your eyes from Leo's stars has been traveling for decades, some of it for centuries. And when you look at Regulus, the bright star at the heart of the lion, you're seeing light that left that star's surface back when your great-grandparents were children. This creates something almost magical. The view you see isn't really happening now. It's a collection of different moments in time, all arriving at your eyes together. One star shows you the 1800s. Another shows you the early 1900s. A faint galaxy in the same patch of sky might be showing you light that started its journey before humans invented writing. Between these stars lies a kind of emptiness that's hard to imagine. In the space around Earth, every cubic centimeter of air contains billions upon billions of atoms. Out there, in the void between stars, you might find just one lonely atom in that same volume. It's not empty the way a vacant room is empty. It's empty in a way that makes the word empty seem insufficient. Stars themselves are massive spheres of hot gas, mostly hydrogen, crushed by their own enormous weight until the pressure and temperature at their cores become so intense that nuclear fusion begins. That's the process that makes stars shine, that sends light streaming out in all directions through space. If you could somehow travel to a planet orbiting one of Leo's stars and look up at the night sky, you'd see something completely different. The familiar lion shape wouldn't be there at all. Stars that look bright and important from Earth might be dim or invisible. Other stars, ones you barely notice from here, might dominate that alien sky. This tells us something profound about perspective. Constellations aren't really features of the universe. They're features of our particular viewpoint, our specific location in space and time. The stars that form Leo aren't traveling together through the galaxy like a pack of cosmic lions. Each one follows its own orbital path around the center of the Milky Way, at its own speed, in its own direction. Over thousands of years, these subtle differences in motion add up. The shape of Leo is actually changing, very slowly. In 50,000 years, that proud lion will look quite different. His mane will be stretched, his body bent into new curves, his tail pointing somewhere else entirely. Given enough time, the pattern will dissolve completely. There's something both humbling and beautiful about this. The constellations that have guided human navigation, inspired our myths, helped us mark the seasons, they're all temporary arrangements. Cosmic coincidences that happen to look meaningful from our small blue planet at this particular moment in galactic time. Your eyes line up these distant suns into familiar shapes, but they exist in a three-dimensional universe where distance and time create relationships far more complex than what we see. Each point of light has its own story, its own age, its own destiny. Some are young and hot and blue. Others are old and cool and red. Some will end their lives in spectacular explosions. Others will simply fade away into darkness. The space between them contains mysteries we're still learning about. Invisible dark matter that we can only detect through its gravitational effects. Streams of high-energy particles racing between the stars. Clouds of gas and dust where new stars are being born. Magnetic fields that stretch across light years, organizing matter in ways we're just beginning to understand. When ancient peoples looked up and saw Leo, they saw the same pattern of stars you see today. They created stories about this celestial lion, wove it into their understanding of seasons and navigation and the divine, but they were looking at essentially the same snapshot of cosmic time that you see now. Human civilization, with all its rises and falls, its empires and discoveries, fits into just a brief moment compared to the slow dance of stars across the galaxy. This makes each clear night special in its own way. You're witnessing a particular arrangement of distant suns that has never existed before in exactly this way, and exactly this way, and exactly down. The light reaching your eyes tonight left those stars years or decades ago, carrying information about distant worlds, distant times, distant possibilities. In a universe where true neighbors are rare and distances are measured in years that light takes to travel, every star you see represents a small miracle of physics and time, a distant furnace of nuclear fire sending its ancient light across the cosmic dark to reach you, here, now, in this brief moment of cosmic history. Human perception creates remarkable illusions when we gaze upward at night. Your brain naturally searches for patterns, connections, meanings in scattered points of light. This ancient tendency shaped how civilizations across the globe interpreted the same stellar arrangements in completely different ways. Consider how distance plays tricks on our understanding. When you observe a constellation like Leo, you're witnessing stars that exist at vastly different distances from Earth. Some shine from 30 light-years away, while others beam their light across hundreds of light-years of empty space. Yet they appear perfectly aligned, creating the illusion of a cohesive group. This phenomenon mirrors something deeply familiar in human experience. Think about how relationships in your own life shift and change over time. People who seem close in one moment may drift apart as years pass. New connections form, while old ones fade into memory. Stars behave similarly, though, on timescales that stretch across millions of years. The concept of cosmic neighbors becomes fascinating when you realize how relative distance truly is. A star 36 light-years away qualifies as remarkably close in astronomical terms. Yet that same distance would require tens of thousands of years to traverse using our fastest spacecraft. Even our nearest stellar neighbors exist in a realm of separation that makes earthly distances seem trivial. Your eye captures light that has traveled unimaginable distances to reach you. Each photon carries information from its source, whether that source lies within our local galactic neighborhood or originates from distant galaxies millions of light-years beyond. The sky doesn't organize these sources by proximity, instead it arranges them purely by direction from your viewing point. This creates something beautiful and profound. When you look toward Leo's constellation, you're peering down an invisible corridor that extends from nearby space all the way to the observable universe's edge. That narrow, angular slice contains layers upon layers of cosmic architecture, stars, nebulae, dust clouds, distant galaxies, vast regions of near emptiness. The retina in your eye processes incoming light without understanding distance or meaning. Specialized cells respond to brightness and color, sending electrical signals toward your brain. Your brain then performs the remarkable task of organizing these signals into recognizable patterns. It searches for edges, alignments, familiar shapes that connect to stored memories, and learned associations. This pattern recognition ability serves you well in daily life. It helps you navigate crowded spaces, interpret facial expressions, find your way through dimly lit rooms. The night sky simply provides one of the largest, most ancient canvases for this neural talent to express itself. Sometimes you might notice how constellation shapes seem to flicker in and out of recognition. Leo's distinctive head might appear clearly one moment, then dissolve back into random points of light when your focus softens. This gentle oscillation between pattern and chaos reveals the perceptual illusion at work. Different cultures throughout history looked at identical star patterns and saw entirely different stories. Animals, mythological figures, the same stellar arrangement that suggests a lion to one civilization might represent a sickle, a backwards question mark, or something completely unrelated to another group of observers. The three-dimensional reality behind these flat patterns contains movement, evolution, cosmic choreography, invisible to casual observation. Stars drift along their individual trajectories through space. Over vast periods of time, familiar constellation shapes gradually distort and eventually disappear entirely, replaced by new accidental alignments. There's something quietly comforting about understanding these layers of illusion and reality. You don't need to hold all this complexity in your mind simultaneously. You can simply appreciate the immediate beauty of stellar patterns while knowing deeper truths exist in the background, waiting for moments when you feel like contemplating them. Standing beneath a clear night sky offers a unique perspective on scale and proximity. The familiar constellation above you consists of distant beacons separated by gulfs that dwarf any earthly measure of distance. Yet from your vantage point, they appear to belong together, creating meaning through pure coincidence of direction. This contrast between appearance and underlying reality provides gentle lessons about perception itself. What you observe isn't always what exists. Patterns can emerge from things that share no true connection. Closeness often proves to be an illusion, created entirely by perspective. Your immediate environment offers a comforting counterpoint to these cosmic distances. The walls around you, the surface you rest upon, the air you breathe, these exist in genuine proximity. Here in your small familiar world, nearness means something tangible, measurable, real. Both realms coexist simultaneously, the intimate scale of your immediate surroundings and the incomprehensible vastness stretching overhead. Neither perspective diminishes the other. Instead, they create a beautiful contrast that highlights the layered nature of existence itself. The gentle rhythm of your breathing, the steady presence of gravity holding you in place, the soft darkness surrounding nearby objects. These immediate sensations anchor you while your mind contemplates distant stellar arrangements. This duality between near and far, small and immense, simple patterns, and complex realities forms part of what makes stargazing such a profoundly human experience. When you look up at the night sky, you're participating in an ancient act of creation. Every time your eyes trace the outline of Leo, you're not discovering something that exists out there in space. You're building it, moment by moment, in the theater of your mind. The stars themselves don't know they're part of a lion. They're simply burning balls of gas, scattered across unimaginable distances, each following its own orbit around the center of our galaxy. Some of these stars are relatively close to us, maybe 50 light-years away. Others are hundreds of light-years distant. But when you look up, all that depth collapses into a flat canvas. Your brain takes these points of light, floating at completely different distances, and treats them as if they all exist on the same surface. It's a bit like looking at your reflection in a window at night. Your face appears to be outside, mixed with the trees and buildings beyond, even though you know they're at totally different distances. This flattening of space is what makes constellation shapes possible in the first place. If you could somehow perceive the true three-dimensional arrangement of these stars, the idea of connecting them with imaginary lines would seem absurd. You'd see points of light scattered through a vast corridor of space, with no more connection to each other than random grains of sand on a beach. But we don't experience the sky that way. Instead, we see patterns, and these patterns feel surprisingly real once they take hold in our minds. You can test this for yourself on any clear night. Find a constellation you know well, maybe the Big Dipper or Orion. Trace its familiar shape with your eyes. Then try to forget what you've learned. Look at those same stars as if you've never seen them before. For a moment, the pattern might dissolve. The stars become just points of light again, scattered randomly across the darkness, but almost without effort, the familiar shape returns. Your mind snaps back to the pattern it knows, like water flowing downhill. This reveals something fascinating about how we construct reality. The constellation isn't really out there, waiting to be discovered. It's something you actively create, over and over again each time you look up. Different cultures have looked at the same arrangement of stars and seen completely different things. Where one group saw a lion, another saw a sickle for harvesting grain. Where some saw a great bear, others saw a wagon or a group of ancestral spirits dancing in the sky. The stars themselves are indifferent to these interpretations. They simply offer their light. Everything else, all the meaning and story and shape, comes from us. There's something both humbling and remarkable about this. On one hand, it shows how much of what we consider real is actually constructed by our minds. On the other hand, it demonstrates the incredible human capacity to find meaning and beauty in the natural world. Consider how a child experiences the night sky for the first time. Without anyone to guide them, they don't see lions or hunters or mythical creatures. They see bright stars, dim stars, and dark spaces between them. The sky is simply a scatter of lights, not a picture book. It's only after someone points upward and says, "See that? That's a lion," that the shape appears. And once it appears, it tends to stick. The pattern gets reinforced through repetition, through shared stories, through star maps and guidebooks. This is how illusions become stable over time. They're supported by collective agreement. The more people who recognize the same pattern, the more real it feels. There's something quietly communal about this process. Constellations are one of the ways humans across different times and places have shared a common view of the universe. You and someone on the opposite side of the planet can both look up and recognize the same arrangement of stars, even if you attach different stories to it. But the shape itself remains a kind of cultural agreement, rather than a physical feature of the cosmos. Now, the stars that make up these patterns aren't standing still. Each one is moving through space, following its own orbital path around the galactic center. This motion is incredibly slow, from our perspective, taking hundreds of millions of years to complete a single orbit. The movement is so gradual that it's called proper motion, and you can't see it happening with your eyes. But over thousands of years, these tiny shifts accumulate. The stars drift, the alignments change, the familiar patterns gradually warp and distort. If you could see the sky as it appeared 50,000 years ago, you'd recognize some of the same stars, but many of the constellation shapes would look different. The lion's mane might be stretched in a different direction. Its body might appear bent or twisted. Its tail might point somewhere else entirely. Go far enough into the past or future, and the shape of Leo would become completely unrecognizable. So the illusion isn't just tied to where you happen to be standing in space. It's also tied to when you happen to be living in time. Right now, at this particular moment in the long history of our galaxy, these stars happen to line up in a way that suggests a lion when viewed from Earth. That alignment is temporary on cosmic timescales. It's a fleeting arrangement that feels permanent within a human lifetime, but is actually just a snapshot, one frame in a very long cosmic film. This adds another layer to the illusion of constellation shapes. The patterns we see are not eternal features of the universe. They're temporary alignments, visible for a brief window in cosmic history, and only from our particular vantage point. Think about how star charts and smartphone apps influence our perception of these patterns. Most maps show constellations as neat, flat shapes arranged on a grid. All the stars are represented as if they exist on the same surface. This approach is practical. It makes the sky easier to navigate and learn, but it also reinforces the idea that the shapes are physically real. If star maps were three-dimensional, instead, showing the actual distances and depths of stars, the idea of constellation as coherent pictures would quickly fall apart. You'd see points of light floating at vastly different distances, connected only by the accident of your viewpoint. But three-dimensional maps are much harder to use. They're difficult to print, difficult to read, difficult to carry around. So we stick with the flat versions, and in doing so, we keep the illusion alive and accessible. Perhaps this illusion serves a valuable purpose, though. If the night sky were presented to us in all its true complexity at once, it might be completely overwhelming. Hundreds of billions of stars in our galaxy alone. Trillions of galaxies beyond that. Distances so vast they make our entire planet seem like a speck of dust. The simple shapes of constellations offer a way to begin engaging with this immensity. They provide something familiar, something manageable, something our minds can grasp and remember. From there, if curiosity leads us deeper, we can start to peel back the layers and discover the true complexity behind the patterns. The illusion becomes a bridge between human scale and cosmic scale, between what we can intuitively understand and what requires scientific instruments to fully appreciate. As Earth rotates beneath us, the entire sky appears to wheel overhead. Stars rise in the east, arc across the night, and set in the west. The constellation shapes move as units, maintaining their familiar outlines as they travel across our field of view. This shared motion reinforces the sense that these star patterns are real, unified objects, but the movement we're seeing is mostly our own. It's our planet spinning beneath us, carrying our viewpoint around, sweeping the stars across our visual field, like distant landmarks, seen from a moving car. The stars themselves aren't moving together in any coordinated way. They're simply being carried across our perspective by Earth's rotation. This is yet another layer of the constellation illusion, the way our own motion creates an appearance of cosmic choreography. When you step back and consider the bigger picture, this whole experience of seeing shapes in the stars might be quite rare in the universe. As far as we know, humans are among the very few beings who look at the night sky and construct pictures from it. Other animals certainly use stars for navigation. Birds migrate by stellar landmarks, and some insects orient themselves by celestial cues. But they don't seem to create stories or mythologies from star patterns. They don't group stars into imaginary shapes or pass down tales about cosmic lions and hunters. The constellation illusion depends on imagination, memory, culture, language, storytelling. It depends on the distinctly human habit of finding meaning and narrative in natural patterns. In this sense, Leo the lion exists, not just because of where certain stars happen to be located, but because of how people have chosen to look at them for thousands of years. That long tradition of shared seeing gives the pattern a kind of cultural weight. It feels real because so many minds have held it in place across generations. But if humanity were to vanish tomorrow, the lion would disappear with us. The stars would continue burning, but the shape that connects them would exist nowhere in the universe. This raises intriguing questions about the nature of reality itself. How much of what we consider real and permanent is actually constructed by our minds, sustained by our collective agreement to see it in certain ways? The constellations offer a gentle reminder that we don't just observe the universe, we actively participate in creating our experience of it, finding patterns and meaning in arrangements of light that by themselves contain no inherent message at all. Stars offer us this curious gift, this gentle deception that shapes how we see the universe around us. When you glance up at a constellation, your mind naturally connects these points of light into something familiar, something with meaning. The lion takes shape in your vision, complete with its proud mane, strong back, curved tail. But this connection, this pattern, exists only because of where you happen to be standing in the cosmos. Your human brain excels at finding order in scattered information. It takes these distant suns, scattered across enormous volumes of space, and weaves them into stories. The lines you trace between stars aren't drawn in space itself. They exist in the realm of perception, in that fascinating place where mind meets universe. Consider what happens when you shift your perspective, even slightly, move to another planet, another star system, and these familiar shapes dissolve completely. The lion vanishes. New patterns emerge from the same stars, forming entirely different pictures. What seemed permanent and meaningful becomes fluid, temporary, dependent on your particular point of view. This isn't cause for disappointment, though. It reveals something profound about how consciousness interacts with reality. You don't just passively observe the universe. You actively participate in creating the version of it that you experience. Your location, your biology, your mind, all collaborate to build the night sky you see. Lying beneath the stars, you can hold both truths simultaneously. The pattern feels real, because it is real, in your experience. The vast distances are real too, stretching far beyond what your senses can directly comprehend. Neither truth cancels the other. They coexist, layered like transparent sheets of meaning. When you trace Leo's outline, you're actually looking down a narrow corridor through space. This corridor extends outward from Earth like an invisible tunnel, collecting everything that happens to fall along that particular line of sight. The constellation isn't really a region of space. It's a direction, a way of looking outward into the cosmic depths. This direction takes you through multiple layers of reality, each separated by distances that challenge comprehension. The nearest star in Leo, the nebula, marks the lion's tail from about 36 light-years away. In galactic terms, this makes it practically a neighbor. If you could map our local region of the Milky Way like a city, the nebula would live just a few blocks from our sun. But even this relatively short distance contains vastness that's hard to grasp. Light from the nebula takes over 3 decades to reach your eyes. The star you see tonight shows you how it appeared when many of today's adults were just learning to walk. Between here and there stretches an ocean of mostly empty space, punctuated by occasional drifting dust, thin wisps of gas, and a rare, wandering star. Moving deeper into Leo's outline, Regulus glows at the lion's heart from about 79 light-years away. This creates a gap of 43 light-years between just these 2 stars. If they were cities on Earth, entire continents would separate them. Yet from your perspective, they appear as close companions, sharing the same small patch of sky. Algeba, helping form the lion's curved head, sits around 130 light-years distant. Now Leo's depth spans nearly 100 light-years from front to back, and we've only considered 3 of its brighter stars. Add the fainter point that flesh out the lion's body, Zosma, Chertan, and others, and the range stretches even further. Some components lie 200 light-years away. A few reach beyond 300. So when you casually trace Leo's familiar shape, you're actually following a 3-dimensional volume of space that extends hundreds of light-years deep. The simple outline that fits comfortably in your field of vision contains a corridor of space vast beyond easy imagination. A light-year measures how far light travels in 1 year, moving at roughly 300,000 kilometers per second. This equals nearly 9.5 trillion kilometers annually. When we say a star lies 100 light-years away, we're describing roughly 950 trillion kilometers of distance. These numbers slip past comprehension like water through fingers. Perhaps it helps to imagine something slower, more human-scaled. If you could walk continuously, day and night without rest, at a steady 5 kilometers per hour, it would take about 225 million years to walk a single light-year. Picture walking 100 of them. That's the scale hidden within the lion's simple outline, a stretch of space you can cover with your thumb held at arm's length. The stars forming Leo weren't born together, don't travel together, don't share common origins. Unlike some constellations that contain actual star clusters, families of suns born from the same cosmic nursery, Leo presents us with unrelated stars that simply happen to align from Earth's viewpoint. This makes its depth not a smooth gradient from near to far, but rather a patchwork of suns scattered at wildly different distances, all projected onto the same flat picture. Imagine standing before a large dark window at night. Someone has placed glowing stickers at various distances, some on the glass itself, others floating meters behind it, still others far down a hallway beyond the window. From your position, they all appear part of the same surface display. The night sky works similarly, collecting lights from vastly different depths and presenting them on the same apparent dome above your head. But Leo's depth extends far beyond even the most distant stars in its pattern. Hidden within this same region of sky, invisible to casual observation, but detectable through telescopes, lie entire galaxies. Each contains billions of stars, vast clouds of gas and dust, all bound together by gravity, into structures larger than our entire local stellar neighborhood. The Leo triplet presents perhaps the most famous example: 3 spiral galaxies, located about 35 million light-years away. This distance transforms our sense of scale completely. Compared to the few hundred light-years spanning Leo's stellar outline, 35 million light-years belongs to an entirely different category of measurement. It's like comparing the width of a room to the distance between continents. When you gaze at Leo, you're not simply looking at a 3-dimensional region within our galaxy. You're also peering far beyond the Milky Way itself, into intergalactic space, at light that began its journey millions of years ago. This ancient light started traveling toward Earth long before modern humans existed, long before the last ice age reshaped our planet's surface, long before the continents settled into their current positions. The photons reaching your eyes tonight carry information from an era when our world looked completely different. They've crossed not just space, but time, bridging eons to deliver their message about distant cosmic events. In this sense, constellation gazing becomes a form of time travel, connecting you directly to the deep past of the universe. All these layers of depth and time exist simultaneously within Leo's familiar outline. The nearby stars, the distant ones, the invisible galaxies, all occupy the same narrow slice of sky from your perspective. Your mind naturally flattens this complexity into something manageable, something beautiful, something that tells a story about lions and legends. This flattening isn't a failure of perception. It's a remarkable achievement. Your consciousness takes in possibly complex, multi-layered information and transforms it into something meaningful, something that can inspire wonder and contemplation. The constellation emerges from the collaboration between cosmic reality and human awareness, neither purely objective nor purely subjective, but something richer than either alone could create. When you gaze up at the constellation Leo, you're witnessing something that goes far beyond what meets the eye. Each point of light carries with it a journey spanning unimaginable distances and unimaginable time. The photons hitting your retina right now, they've been traveling for decades, some for millions of years, all arriving at this precise moment to paint that familiar lion shape across the darkness. Think about this for a second. The light from Denebola has been racing through space for 36 years. When that light began its journey, the world was a different place entirely. Meanwhile, light from Regulus started its trip nearly 80 years ago, carrying with it an image of that star from before many of us were even born. And then there's Algeba, showing us a stellar portrait from over a century in the past. But here's where it gets really mind-bending. Scattered throughout that same patch of sky, hidden behind the constellation's familiar outline, lie galaxies so distant their light has been traveling for 35 million years. When that ancient light first departed those far-off stellar cities, Earth was still figuring out what mammals might become. All of these different eras, all these vastly different distances, they converge in your vision simultaneously. It's like looking at a photo album where every page represents a different decade. But somehow all the images appear layered on top of each other, creating one composite picture that spans geological time. The universe has this peculiar way of compressing eons into a single glance. Every time you look up at Leo, you're essentially becoming a time traveler, witnessing multiple moments from cosmic history all at once. The stars aren't just scattered across space, they're scattered across time itself. Now imagine if you could somehow perceive distance the way you perceive color or brightness. Instead of that flat, two-dimensional line drawing stretched across the sky, you'd see something completely different. A three-dimensional cloud of lights, some blazing nearby, others dimmed by incredible distance, fading into hazy glows at the very limits of perception. The constellation would lose its shape entirely. There'd be no clear outline, no definitive boundary, just a gradual thinning of stellar points as they recede into the cosmic depths. That's actually much closer to reality, but our human senses give us this flattened, simplified version instead. And maybe that's not such a bad thing. There's something almost merciful about this limitation, this inability to perceive the full, overwhelming scale of what we're looking at. It allows us to appreciate the night sky without being constantly crushed by its immensity. Even the stars that appear relatively close to each other, they're separated by voids so enormous that traveling between them would mean crossing decades of empty space. If you somehow journeyed from Regulus to Algeba, roughly 50 light years, most of that trip would be spent in absolute darkness, in regions where nothing much happens at all. The Milky Way, despite its name suggesting abundance, is mostly vacant real estate. Stars scattered like isolated islands in an ocean of nothingness. From far away it looks crowded, but up close, you'd be struck by how much emptiness exists between each point of light. This emptiness, it's part of the hidden architecture of every constellation we see. The spaces between the stars are as important as the stars themselves, creating the vast stage on which this cosmic drama plays out. When you trace Leo's outline with your finger, you're performing an extraordinary mental feat. You're taking a region of space that spans hundreds of light years in depth, millions when you include those background galaxies, and you're compressing it into a simple two-dimensional shape that fits comfortably in your field of view. Your mind somehow holds both versions simultaneously. The simple, beautiful pattern of the lion, and the staggering reality of depth and time that lies behind it. You don't need to consciously think about those vast distances to appreciate the constellation, but knowing they're there adds a subtle richness to the experience. It's like listening to a piece of music while quietly knowing the complex mathematical relationships between the notes. The knowledge doesn't interfere with the beauty, it deepens it. And all of this entire arrangement we call Leo, it's temporary. The stars aren't fixed in place, like dots on a canvas. Over thousands, millions of years, they drift and wander. Some edge closer to us, others recede into greater distance. Some will eventually explode in spectacular supernovae, others will simply fade and cool into stellar corpses. The depth you're seeing tonight, this particular layering of near and far, of past and present, it's just a snapshot in an ongoing process of cosmic change. The Leo our descendants see thousands of years from now will be subtly different, its hidden depths rearranged by the slow dance of stellar motion. There's something quietly comforting about this impermanence. It reminds us that even on cosmic scales, nothing stays exactly the same forever. The universe is always in motion, always becoming something slightly different, even when everything appears perfectly still. Picture yourself standing somewhere dark enough to really see the stars. The air is cool against your skin, the ground solid beneath your feet. You tilt your head back and find that familiar lion shape. Without changing what you see, just let your mind add that extra dimension, that awareness of depth stretching far beyond what your eyes can reach. You don't need to visualize it perfectly, just hold the idea gently, like a soft understanding sitting quietly behind the image of the constellation. There's no test to pass, no complex concepts to master, just this gentle recognition that the sky is far deeper, far more layered than it first appears. Long before Regulus announces itself as the brightest star in Leo, there's this quiet moment where the constellation feels almost empty, as if the darkness is holding its breath, waiting for you to notice something important. Then, without fanfare, one star begins to distinguish itself from the rest, not by flickering or changing, but simply by maintaining this steady, patient presence that gradually draws your attention. That gentle insistence is how you first encounter Regulus, the star often called the Heart of Leo. If you were introducing someone to this constellation, Regulus would likely be your starting point. It has this quality of being noticeable without being overwhelming, bright enough to serve as an anchor for the entire stellar pattern. The name, Regulus, means little king in Latin, a title that reflects how various cultures have regarded this star throughout history. Ancient observers associated it with royalty, with power, with the changing seasons, its position along the ecliptic, the path the sun and planets follow across the sky, made it feel like an active participant in celestial events rather than just another background light. When you look at Regulus, you see what appears to be a single, clean point of blue-white light. But even that simple appearance conceals layers of complexity that would have amazed ancient stargazers. There's something remarkable about a star that spins so wildly, it reshapes itself. Regulus, the Heart of Leo, completes a full rotation in just 16 hours. Our sun, by comparison, takes nearly a month to turn once. This breakneck spinning does something extraordinary. It literally flattens the star. Picture a ball of dough being spun faster and faster. It bulges at the middle, compresses at the ends. That's exactly what happens to Regulus. The equator bulges outward, the poles squeeze inward. If you could somehow travel there, you wouldn't see a perfect sphere, but rather a cosmic squashed ball, gently flattened by its own restless motion. This distortion creates temperature differences across the star's surface. The poles burn hotter and brighter than the equatorial regions. It's a reminder that what appears calm from our distant vantage point can be extraordinarily dynamic up close. The serene dot of light we see harbors incredible violence and motion within. Scientists believe this rapid spin might tell a story of stellar theft. Regulus likely has a companion, possibly a white dwarf, orbiting nearby. The theory suggests that long ago, Regulus may have stolen material from this companion. This cosmic robbery could explain why the star spins so frantically today. It carries the evidence of this ancient interaction, written into its very motion. The idea of stars influencing each other across vast emptiness speaks to something profound about connection. Even in space, relationships form. Not the warm, familiar bonds we know on Earth, but gravitational partnerships that play out over millions of years. Matter flows between stellar companions, speeds change, orbits evolve. These are relationships measured in cosmic time. At roughly 3 to 4 times our sun's mass, Regulus burns much brighter and hotter. Its surface reaches temperatures of 12,000 degrees Celsius or more. This intense heat comes from the nuclear furnace at its core, where hydrogen atoms get crushed together under enormous pressure, forming helium and releasing tremendous energy in the process. That energy begins a remarkable journey. It bounces around inside the star for thousands of years, gradually working its way outward. Only then does it finally escape as light and begin the next leg of its journey, the 79-year trip to Earth. So, when you see Regulus tonight, you're witnessing the end result of nuclear reactions that began deep inside the star, long before that light ever left its surface. This creates a strange layering of time. The fusion reactions happened thousands of years ago. The light left the star's surface nearly 80 years ago. And now it arrives at your eye in this present moment. You're seeing the accumulated history of countless tiny stellar events, all compressed into a single point of light. The distance of 79 light-years places Regulus in what astronomers call our local stellar neighborhood. In a galaxy that spans 100,000 light-years, this star sits practically next door. Yet that neighborly distance still represents an almost incomprehensible journey. The light reaching your eyes tonight began its trip before many people alive today were born. It departed when the world was different, when technology and culture bore little resemblance to what we know now. That light traveled through the changing decades, carrying with it the unchanged message of a distant star. There's something quietly grounding about this connection between present moment and distant past. Ancient civilizations recognized Regulus as special. Its position near the ecliptic, the path followed by sun, moon, and planets, made it a celestial landmark. Some traditions called it one of the royal stars, associated with power and leadership. Its rising and setting helped mark seasonal changes and ceremonial times. For people living thousands of years ago, the night sky served as clock and calendar. No artificial timepieces existed, just the steady rise and fall of stars like Regulus. Night after night, year after year, it returned to the same position. This reliability built familiarity, and familiarity built meaning. The metaphor of Regulus as the heart of the lion carries more weight than mere poetry. In the pattern of Leo, this star really does occupy a central position. The curve of the lion's head seems to wrap around it. The body extends away from it. The tail points back toward it. Visually, it feels like a core, a place where the entire shape finds balance. But this centrality exists only from our perspective. Physically in space, Regulus is just one star among many, at its own distance, following its own path around the galaxy. The idea of it being the heart is something we've projected onto it. A human interpretation that makes the random pattern feel more alive, more meaningful. This layering of meaning represents how we connect with the cosmos. We take something distant and abstract, give it a role, a position, a story. The star becomes more than burning gas. It becomes a character in our understanding of the sky. If you could view this same region of space from another location in the galaxy, perhaps 100 light-years away, the perspective would change dramatically. Regulus might appear dim and unremarkable. The shape of Leo would likely become unrecognizable. The heart of the lion would be just another anonymous dot. So the importance of Regulus, like the shape of Leo itself, depends entirely on where you stand. This doesn't diminish its meaning, it just makes that meaning local. There's comfort in recognizing that significance doesn't need to be universal to be real. It can belong to a place, a culture, a moment in time, and still matter deeply to those who experience it. The pale blue-white color of Regulus reveals its temperature, much hotter than our yellow sun. This heat drives the intense nuclear fusion in its core, the process that keeps the star shining across the decades. Those countless fusion reactions, squeezed together under pressure that defies earthly comparison, create the energy that eventually becomes the light in our sky. Regulus also belongs to a larger stellar family. At great distances, at least 3 smaller companion stars orbit around it, forming a loose gravitational group that travels together through the galaxy. It's a reminder that even individual stars often exist as part of larger systems, bound by invisible forces across enormous spans of space. Within the constellation Leo, Regulus sits at a middle distance compared to other stars. Some members of the pattern lie closer to us, others much farther away. If you imagine Leo as a layered cloud of points extending into space, Regulus occupies somewhere near the center of that depth. This creates an interesting perspective. If you could draw a line from Earth through Regulus and continue onward, you would pass beyond the star into deeper regions of the Milky Way, through fields of stars too faint to see, through dust clouds and gas, eventually beyond the galaxy itself into intergalactic space. All of this lies hidden behind the quiet light of Regulus, concealed in the same narrow corridor of sky. This shifts how we might think about the star. Instead of a destination, it becomes a gateway. You're not just looking at Regulus, you're looking through it, toward realms of space that stretch far beyond. Like all stars in our galaxy, Regulus orbits the galactic center. This vast orbit takes hundreds of millions of years to complete. During that time, the star drifts relative to others, slowly changing its position in our sky. These changes are too small to notice now, but over tens of thousands of years, they will become visible. The heart of the lion will move. The shape of Leo will stretch and shift. Even this anchoring point in the constellation plays only a temporary role. There's a gentle lesson here about the nature of stability. Things can feel permanent and central in our experience, even while quietly changing underneath. When you step outside on a clear night and scan the sky, looking for that steady point of light, you're participating in an ancient human activity. The same star that guided navigators and marked seasons for countless generations continues to shine in your sky. That light carries with it the story of nuclear fire, rapid rotation, stellar companionship, and the long journey through space to reach your eyes in this quiet moment. Looking up at the night sky, most people can spot the constellation Leo without knowing much about what they're actually seeing. There's Regulus, glowing steadily as the heart of the lion, surrounded by other bright points that form this familiar shape. It's perfectly fine to appreciate it, simply to feel that quiet satisfaction of recognizing something overhead without diving into the complex details of distance and motion and stellar evolution. But here's where things get interesting. Regulus isn't just a point of light, it's a massive spinning star, rotating so fast it's actually flattened at its poles. The light hitting your eyes right now left that star decades ago, traveling across nearly 80 light-years of empty space to reach you. While you've been living your entire life, that photon has been racing through the void at incredible speed, carrying information about a sun that's much larger and hotter than our own. This brings us to something quite profound about perspective. When the moon occasionally drifts in front of Regulus, blocking it from view for a brief time, you're witnessing an alignment between something just over a light second away and something nearly 80 light-years distant. The moon, close enough that radio signals bounce off it almost instantly, lines up perfectly with a star so far away that its light began the journey when you were probably much younger. It's like watching a coin held at arm's length eclipse a distant mountain, except the scales involved stretch across decades of travel time for light itself. Now, here's where our understanding of the night sky takes a fascinating turn. All those stars in Leo, the ones that seem to belong together in this celestial lion, are actually strangers to each other. They're not traveling as a group, they're not gravitationally bound, they don't form any kind of stellar family or cluster. What you're seeing is more like a cross-section through space, a thin slice of the galaxy, where several distant suns happen to line up from Earth's viewpoint. Think of it this way. Imagine standing on a hilltop at night, looking down at a highway. You see streams of headlights and taillights that appear to flow together, but each car is going to a completely different destination. Some will take the next exit, others will drive for hundreds of miles before stopping. From your distant perspective, they look coordinated, but they're actually individual travelers on separate journeys. The stars in Leo are doing exactly the same thing, just on a scale so vast and slow that it's almost impossible to grasp. Each star is following its own orbit around the center of the Milky Way galaxy. Some orbit faster because they're closer to the galactic center, others move more slowly in the outer regions. Some have tilted paths that carry them above or below the main plane of the galaxy. The result is that over enormous stretches of time, the constellation will slowly stretch and distort and eventually unravel completely. This gets even more interesting when you consider what it means for stars to actually encounter each other. Space is so incredibly empty that even in relatively crowded regions of the galaxy, stars can pass by each other at distances of trillions of kilometers without ever coming close enough to gravitationally interact. The average distance between stars in our part of the galaxy is several light years. If you scaled our sun and its nearest neighbor down to grains of sand, they would still be kilometers apart. So when astronomers say that the stars in Leo will never meet, they're talking about something quite remarkable. These stellar neighbors in our sky, these points of light that seem to belong together, will drift apart over millions of years without ever coming anywhere near each other. They'll follow their separate paths around the galaxy, slowly sliding apart in Earth's sky, until the familiar shape of the lion is completely lost. But there's another layer to this cosmic loneliness. Each star in Leo is also at a different stage of its life cycle. Some are young and hot, burning through their nuclear fuel quickly and shining with intense brightness. Others are middle-aged, like our Sun, settled into a long, stable period of steady energy output. A few may already be approaching the end of their main sequence phase, beginning to swell or change as their internal fusion processes shift. These stellar life cycles don't synchronize with each other. A star that's bright and prominent in Leo today may fade or even explode in the distant future, while another star, currently too faint to see with the naked eye, might drift into a more prominent position and become the new heart of the lion. The cast of characters changes over geological time, even as the characters themselves drift apart through space. There's something quietly profound about this realization. The constellation you can find and recognize and return to night after night is actually a temporary arrangement, a fleeting moment in the galaxy's slow rotation, when several unrelated stars happen to line up just right from Earth's perspective. It's like looking at a photograph of strangers who were accidentally captured in the same frame. Except, the photograph took millions of years to expose, and by the time you're viewing it, the subjects have already begun walking away from each other. This doesn't diminish the beauty or meaning of Leo in any way. If anything, it adds another dimension to the experience of stargazing. You're not just looking at a pattern in the sky, you're looking at a cross-section through space and time, a glimpse into the vast, slow dance of stellar motion that's been unfolding for billions of years and will continue long after our planet is gone. Each point of light represents an entire solar system, following its own ancient path through the galaxy, temporarily aligned to create this familiar shape that humans have been recognizing and naming for thousands of years. The next time you spot Leo overhead, you might find yourself thinking about all those separate journeys happening simultaneously. Regulus spinning rapidly as it orbits the galactic center, the nebula following its own slightly different path, Algeba and Zosma and the others all pursuing their individual courses through space. They appear to move together across your sky each night, rising and setting in formation. But that's just Earth's rotation creating an illusion of unity among these cosmic wanderers. The universe operates on a timescale that challenges our everyday understanding of together. When we gaze upward at familiar star patterns, we witness something remarkable, yet deceptive. These celestial lights, appearing so unified in our night sky, tell a story of profound isolation that unfolds across billions of years. Consider the vast age of our cosmos, stretching back some 13.8 billion years. Throughout most of this incomprehensible span, our galaxy has been a stellar nursery, birthing new suns in waves and cycles. The stars we see grouped together overhead didn't emerge simultaneously from some cosmic assembly line. Instead, they represent different chapters in galactic history, separated by hundreds of millions, even billions of years. Some of these distant suns are relatively young, cosmic teenagers that formed when Earth was already ancient. Others predate our solar system entirely, burning steadily since the galaxy's youth. This temporal separation adds a haunting dimension to their apparent unity. We're not simply looking at objects scattered across space, we're looking backward through time itself, seeing lights that began their journeys toward us at vastly different moments in cosmic history. Think of travelers on a lengthy highway, each starting their journey from different cities, at different times, heading toward different destinations. From an airplane window high above, you might glimpse several vehicles within the same stretch of road, appearing to move together. Yet each driver carries their own story, their own origin, their own endpoint. The stars above us are engaged in journeys of this kind. Only the distances involved dwarf anything we can readily comprehend. Space itself participates in this grand separation. On the largest scales, the very fabric of the universe continues expanding, carrying distant galaxies away from us, like boats drifting apart on a slowly widening river. While this expansion doesn't dramatically affect stars within our own galaxy, it influences the broader cosmic stage on which everything unfolds. Those faint background galaxies, barely visible behind the brighter foreground stars, are slowly receding beyond the point where their light will ever reach us again. This adds a sense of finality to cosmic separation. Given enough time, vast portions of the universe will simply vanish from view, not because they've been destroyed, but because the expanding space between us will stretch their light beyond detection. It's a gentle kind of cosmic farewell, played out over timescales that make human history seem like a brief flicker. Gravity, the fundamental force that shapes cosmic architecture, might seem like it would draw these distant stars together. After all, gravity builds solar systems, holds star clusters in loose embrace, and sculpts entire galaxies into spiraling cathedrals of light. But gravity's strength depends critically on both mass and distance. As objects move farther apart, gravitational attraction weakens dramatically. The stars in those familiar patterns overhead are separated by such enormous distances that their gravitational influence on each other becomes essentially zero. They don't feel each other's presence in any meaningful way. They're like strangers passing through the same neighborhood, unaware of each other's existence. This stands in stark contrast to genuine star clusters, where dozens or hundreds of stars, born from the same stellar nursery, remain loosely bound by their mutual gravitational attraction. In those dense stellar communities, stars can truly interact. They can alter each other's orbits, exchange material, and in rare dramatic cases, even collide or merge. But the scattered stars of familiar constellations lack this intimacy. They were born in different places, at different times, and will continue their separate journeys long after the patterns we recognize have faded into new configurations. Time will eventually reveal this separation in ways our brief human lifespans cannot witness directly. Fast forward 1 million years, and familiar star patterns would appear slightly stretched, subtly different, but still recognizable. Jump ahead 10 million years, and the changes become more obvious. The graceful curves we know would begin to bend and distort. After 100 million years, most recognizable patterns would dissolve entirely, their component stars scattered across new regions of sky. Looking ahead 1 billion years, some of these stars would no longer exist in their current form. Some would have swollen into red giants, others would have shed their outer layers in beautiful but terminal displays. A few might have ended their lives in quiet fade-outs or spectacular explosions. Throughout all these transformations, the fundamental isolation would remain. These stars' paths might cross in the sense that they pass through similar regions of the galaxy, but the probability of actual close encounters remains vanishingly small. This isolation isn't an exaggeration or poetic metaphor. It's a realistic description of how separated celestial objects truly are, even when they appear neighborly in our sky. The universe operates on scales where true meetings between stars are extraordinary events, not everyday occurrences. Yet, from our earthbound perspective, these distant suns feel unified, coherent, belonging together in ways that comfort and inspire us. This perception isn't wrong. It's simply operating on a different level of truth. The patterns exist in our experience, in our culture, in our shared human story of finding meaning in the night sky. Meanwhile, in the physical universe, each star follows its own trajectory through space and time. There's something deeply moving about this duality. It mirrors aspects of human experience in unexpected ways. We can stand in crowds, surrounded by other people, while knowing that each person there carries their own history, their own dreams, their own path that only briefly intersects with ours. The stars above us participate in a similar kind of togetherness, sharing our field of view without sharing our journey. Even the fundamental forces that govern cosmic behavior respect this separation. Information itself, including gravitational influence, travels no faster than light speed. If one star suddenly changed, exploded, or vanished, the gravitational effect of that transformation would take years, decades, or centuries to reach another star. So even in a universe where everything connects to everything else through invisible threads of force, those connections are delayed by distance and time. Each star exists within its own small domain of spacetime, its own quiet sphere of influence, connected to the broader galaxy only through slow, gentle forces that play out over immense periods. They inhabit separate bubbles of immediate causation, isolated not just by space, but by the fundamental speed limit of physical interaction. From Earth, the night sky offers us a kind of visual unity that smooths over this underlying complexity. The stars appear to move together, maintaining their familiar relationships across the seasons. The patterns hold, the night feels coherent and manageable. This simplification isn't deceptive, it's a gift of perspective, giving us something stable to recognize and navigate by. But the deeper reality doesn't diminish this gift, it enriches it. We can look upward and see meaningful patterns, mythological figures, navigational aids. We can also look upward and see a collection of distant suns, each burning in solitude across vast reaches of space and time. Both perspectives coexist, both carry truth, both contribute to our understanding of where we stand in the cosmic story. In the rare cases where stars do encounter each other closely, the results can be dramatic. In dense stellar neighborhoods, such as the cores of ancient star clusters or the crowded centers of galaxies, stars can pass close enough to exchange material, alter each other's orbits, or even collide and merge into larger, more massive objects. These encounters release enormous energies and reshape local stellar environments in profound ways. But the familiar star patterns we know occupy relatively quiet galactic suburbs, where such encounters remain extraordinarily unlikely. The stars maintain their solitary journeys, sharing our view of them without sharing their destinations, like distant light scattered across a dark landscape, each illuminating its own small patch of the cosmic wilderness. Imagine the ground beneath your feet, slowly releasing its grip. You drift upward, not with the roar of rockets, but in perfect silence. The Earth shrinks below, and something remarkable begins to happen. The familiar patterns you know so well, those neat shapes drawn across the night sky, start to come apart. What we see from Earth is really just an illusion of flatness. The constellation Leo appears as a tidy outline, something you can trace with your finger in seconds. But that flat picture, pressed against the dome of night, is actually a trick of perspective. When you step away from our single viewpoint, everything changes. The stars we group together aren't really together at all. They're scattered through an enormous volume of space, like lanterns hanging in a vast dark room. Some near the door, others far against the back wall, all randomly placed. From the doorway, you might see a pattern, but walk into that room and you realize the lanterns fill the entire space. Leo's apparent width in our sky spans about 50 degrees. That's roughly 5 fists held at arm's length. It seems manageable, contained, but translate that angle into real distance, and something breathtaking emerges. Using an average distance of around 150 light-years for Leo's stars, that 50-degree span becomes more than 130 light-years across. Think about what that means for a moment. Our entire solar system, including that distant cloud of comets at its edge, spans maybe 2 light-years at most. You could line up dozens of solar systems, side by side, across Leo's true width. The scale becomes almost impossible to grasp. But width is just the beginning. These stars aren't arranged on a flat surface like a painting. They have depth, tremendous depth. Some of Leo's stars sit just a few dozen light-years away. Others lurk more than 300 light-years distant. That creates a three-dimensional region of space, hundreds of light-years deep. A light-year, remember, stretches across 9.5 trillion kilometers. At the speed of a commercial airliner, crossing just 1 light-year would take over 1 million years. When we say Leo spans hundreds of light-years in every direction, we're talking about distances that dwarf any human journey. Yet somehow, all of that immensity fits into a shape you can cup with your hands against the night sky. It's a humbling thought, really. The universe has this way of hiding its true scale behind familiar patterns. Leo's stars don't float in empty void, either. They're part of our galaxy structure, scattered through the same spiral arm where our sun lives. About halfway out from the Milky Way center, some stars drift slightly above the galaxy's main plane, others slightly below. Some edge toward the inner spiral arm, others towards the outer regions. This gives the constellation a kind of thickness, a vertical spread, that adds yet another dimension to its real extent. Picture Leo from far above our galaxy, looking down at the Milky Way like a glowing pinwheel. From that perspective, you wouldn't see a lion at all, just a loose scattering of stars across one small patch of spiral arm. There would be no obvious shape, no head or tail, just points of light in a sea of countless others. The lion exists only when viewed from Earth. This realization brings up something profound about boundaries and centers. We talk about Leo as if it has natural edges, a clear beginning and end. But stretch it across real space, and those boundaries disappear. The constellation becomes something we've imposed on the universe, not something the universe has built for us. Consider a journey between Leo's stars. Start at Denebola, the lion's tail, 36 light-years away. Even traveling at light speed, the ultimate speed limit, that journey takes 36 years. From Denebola, our sun becomes just another faint point among many others. Turn toward Regulus, the lion's heart, another 40+ light-years through mostly empty space, with only occasional distant stars drifting past. At Regulus, you'd find a fast-spinning, flattened star blazing with tremendous energy. From this new vantage point, both Denebola and Earth are just two more dots in a vast field. Continue to Algeba, another 50 light-years away, more decades crossing darkness, accompanied only by the faint glow of distant stars and the soft haze of the Milky Way itself. Moving from star to star within Leo would take centuries. Even at light speed, that's what it truly means to stretch a constellation across real space. Leo's true size puts it in interesting company. A typical open star cluster, where stars are born together and stay loosely bound, might span a few dozen light-years. Leo is several times larger than that. Giant molecular clouds, the stellar nurseries where new stars form, can stretch hundreds of light-years across. Leo's dimensions match those cosmic cradles. It's remarkable, really. Leo isn't actually a cluster or cloud, just a random pattern of unrelated stars. Yet its apparent size rivals some of the galaxy's most significant structures. Compared to dwarf galaxies which span thousands of light-years, Leo remains modest. But among the star groups we commonly discuss, it's quite substantial. The scale doesn't stop with Leo's stars, though, behind the constellation. In that same corridor of sky lie distant galaxies. They're not part of Leo physically, but they occupy the same line of sight, the same stretch of space extending outward from Earth. The Leo triplet, three galaxies that appear to dance together, sits 35 million light-years away. Beyond them lie more galaxies, clusters of galaxies, vast regions where few stars exist at all. So when you truly stretch Leo across real space, you're not just spanning the few hundred light-years of its stars. You're looking down a corridor that extends billions of light-years deep. It makes you wonder about perception and reality. Every pattern we see in the night sky is really just a snapshot from one very specific location, our small rocky world orbiting an ordinary star. Move anywhere else in the galaxy, and all those familiar shapes would rearrange themselves, or disappear entirely. Perhaps that's what makes these discoveries so compelling. They remind us that the universe is far stranger, far more vast and beautiful than our everyday experience suggests. What looks simple from here becomes wonderfully complex when we dig deeper. The night sky presents us with one of the most beautiful illusions in nature. When you look up at the constellation Leo, you're seeing what appears to be a flat pattern, a simple lion shape traced against the darkness. But that flatness, that sense of stars arranged on some distant dome, is just the beginning of a much deeper story. What we call depth in space operates differently than the depth you experience in your everyday world. When you walk through a room, you understand depth by how long it takes to reach the far wall, by how objects overlap and change as you move. But in Leo, depth means something far more vast, something that stretches your imagination in ways that feel almost impossible. The closest stars in Leo sit about 30 light-years away from us. That distance alone represents a journey so long that light itself, racing at the fastest possible speed, takes 3 decades to complete it. Yet these nearby stars are practically neighbors compared to what lies beyond them. They exist in what astronomers call our local stellar neighborhood, a region of space that feels quiet and spacious. By galactic standards, stars in this nearby layer drift through space with plenty of room between them, each following its own ancient orbit around the center of our galaxy. If you could somehow travel to this region, you'd find yourself in a calm part of the Milky Way, where stars are scattered rather than crowded, where the density of matter remains relatively low. But Leo's depth doesn't stop there. As your gaze penetrates deeper into space, you encounter the middle layer of the constellation, where many of its most recognizable stars actually live. Regulus, that bright point that marks the heart of the Lion, sits about 79 light-years away. Other familiar stars in Leo's pattern lie scattered between 70 and 200 light-years from Earth. This middle region represents a different kind of stellar neighborhood. Here, space grows slightly more crowded, filled with a richer mix of stellar types and ages. Young, hot stars burn brilliantly alongside older, cooler ones that glow with a softer light. Binary star systems dance their gravitational waltz, while clouds of dust catch and reflect starlight in ways too subtle for our eyes to detect from such enormous distances. What's remarkable about this arrangement is how temporary it all is. The stars we connect to form Leo's shape aren't actually connected at all. They simply happen to lie in roughly the same direction from our viewpoint on Earth. Over millions of years, these stars will drift apart, following their separate paths through the galaxy until Leo's familiar pattern dissolves completely. Moving even deeper into this corridor of space, you eventually leave behind the stars that form Leo's recognizable outline. Beyond a few hundred light-years, the constellation as we know it fades into the background population of our galaxy, yet the depth continues, filled with countless faint stars too distant and dim for us to see without telescopes. This deeper layer of space tells a different kind of story. Here you find red dwarfs that will burn for trillions of years, ancient white dwarfs that represent the final fate of sun-like stars, and massive giants nearing the end of their lives. Many of these stars have been shining since before our solar system even formed, carrying within their light the history of cosmic evolution. The philosophical weight of this depth becomes almost overwhelming when you consider what it means for our perception of the universe. Every time you trace Leo's outline with your eyes, you're looking down a tunnel that extends far beyond our own galaxy. Your gaze passes through layers of space and time, collecting light from objects separated by millions of years of travel time. At the far end of this tunnel, beyond the edge of the Milky Way itself, lie other galaxies. The Leo triplet, a group of spiral galaxies, about 35 million light-years away, represents just one landmark in this vast cosmic landscape. Each of these distant galaxies contains billions of stars, entire stellar cities drifting through the cosmic web of matter that structures the universe on its largest scales. Think about what this means for the simple act of stargazing. When you step outside and look up at Leo, your eyes are collecting photons that have traveled for vastly different amounts of time to reach you. Light from the nearest stars in the constellation left those distant suns just a few decades ago. Light from the most distant galaxies in the same direction has been traveling since before complex life appeared on Earth. This mixing of light from different eras creates something like a temporal layering in your vision. You're not just looking across space when you observe Leo, you're looking across time. The constellation becomes a kind of time machine, delivering information from multiple epochs of cosmic history simultaneously. The strange thing about astronomical distance is how it challenges our everyday understanding of what it means for something to have size. Leo occupies a specific angular area of the sky, a measurable portion of the celestial sphere, but its true extent in three-dimensional space defies easy description. How do you define the boundaries of something that stretches from a few dozen light-years away to the edge of the observable universe? Astronomers have learned to think about size in different ways when dealing with such scales. Angular size describes how much of the sky an object appears to cover. Physical size attempts to measure actual dimensions in space. And then there's what we might call narrative size, the scope of the story an object tells about the universe and our place within it. Leo contains all these different kinds of size simultaneously. Its angular size is modest, easily covered by an outstretched hand. Its physical size encompasses a region of space larger than most human minds can truly comprehend. Its narrative size connects us to fundamental questions about time, distance, and the nature of cosmic structure. Standing beneath such vastness might seem humbling, even intimidating. But there's something oddly comforting about it too. The same pattern you can trace with your finger on a star chart opens onto depths that reach back billions of years into cosmic history. It's as if the universe has arranged itself to be approachable at a human sailing, while simultaneously revealing its true immensity to anyone curious enough to look deeper. This accessibility of the cosmic scale through simple observation represents one of astronomy's greatest gifts. You don't need complicated equipment or years of training to begin this journey into depth. You just need to look up, find that familiar line shape, and let your mind quietly stretch the pattern outward into the layered darkness beyond. The depth of Leo reminds us that the universe operates on scales that dwarf human experience, while remaining somehow within reach of human curiosity. Every photon that reaches your eyes from that direction carries information across gulfs of space and time that boggle the imagination, yet the end result is something as simple and beautiful as a pattern of bright points against the night sky. Looking out into the direction we call Leo, we're essentially peering down a cosmic corridor that extends far beyond anything our minds can easily grasp. The stars that form the familiar lion shape, they're actually scattered across hundreds of light years, each one sitting at its own distance from us, like scattered lampposts along a very long road. But here's where things get interesting. That road doesn't end with the constellation's stars. It keeps going, stretching through our galaxy, and then beyond it, out into the vast spaces between galaxies. Out there, in those seemingly empty regions, matter becomes so sparse that a single atom might drift through space for thousands of miles before bumping into another atom. When astronomers look deeper into Leo's direction, they find entire groups of galaxies. There's something called the Leo triplet, 3 spiral galaxies locked in a slow gravitational dance with each other. Their spiral arms get stretched and twisted as they pull on one another across millions of years. Beyond those, there are clusters of galaxies, and then larger structures, filaments of galaxies, that stretch across hundreds of millions of light years like cosmic spiderwebs. This creates something almost philosophical about what Leo actually is. If you only think about its width across our night sky, Leo seems manageable, maybe a few fist widths when you hold your hand up to the stars. Add in the depth of just the constellation stars, and Leo becomes a 3-dimensional cloud, a loose swarm of suns drifting through space together. But include the full depth, all the way out to those distant galaxy clusters, and Leo transforms into something much stranger. It stops being an object and becomes more like a perspective, a line of sight that cuts through the entire visible universe in that direction. The lion becomes as big as the universe itself, at least in that one direction. Professional astronomers have a practical way of dealing with this mind-bending depth. They treat constellations not as physical structures, but as regions of the sky, like sections on a map. When they say a galaxy or a comet is in Leo, they don't mean it's physically connected to the lion's stars. They just mean it appears in that part of the sky when viewed from Earth. This makes Leo, fundamentally, a direction rather than a place. It's like standing at the entrance of an incredibly long hallway. The constellation stars are like doors lining the walls near you. The distant galaxies are like windows at the far end, looking out onto even more distant structures. Everything you see is framed by the same doorway, part of the same view, but existing at completely different distances. If you could somehow travel along this line of sight, drifting away from Earth and into Leo's depths, you'd experience these layers directly. The sun would quickly fade behind you, becoming just another point of light. The familiar patterns of Earth's constellations would dissolve, as your perspective shifted, you'd pass close to the constellation's bright stars, Regulus, Denebula, each one revealing itself as a blazing sun with its own family of planets and dust. Between these stellar encounters, you'd spend long stretches in deep space, where the nearest star might be several light years away and the darkness feels almost complete. Eventually, you'd see the Milky Way itself start to shrink behind you, forming a glowing disk in your rear view. Ahead, faint smudges of light would appear, the first hints of other galaxies entirely. By the time you reach the Leo triplet, those three dancing spiral galaxies, the very concept of Leo as a lion-shaped pattern would have lost all meaning. You'd be surrounded by countless galaxies, each one a tiny island of light in a vast dark ocean. The constellation would feel like a distant memory from a place very far behind you. But here's something beautiful about depth that you can experience without traveling anywhere. Even from your backyard, with just your eyes or a pair of binoculars, you can start to feel these layers. Some stars twinkle more than others, partly due to our atmosphere, but it gives a subtle texture to the view. Through a telescope, that texture deepens dramatically. You might see a bright star in the foreground, then notice a faint cluster of stars behind it, and then spot a hazy patch of light that turns out to be an entire galaxy far beyond both. It's like looking into a forest. The nearest trees are clear and detailed. Farther back the shapes blur together, and at the very back, everything becomes a wall of green and shadow. Leo, when you include all its depth, is like that forest, only made of light and darkness instead of leaves and trunks. And there's another layer to consider. As you look deeper into space, you're also looking further back in time. The light from nearby stars left them decades ago. Light from distant stars in our galaxy left them thousands or millions of years ago. Light from those far-off galaxies began its journey tens or hundreds of millions of years ago, sometimes billions. So Leo's tunnel is also a tunnel through history. You're not just looking across space, you're looking across eras, across different moments in cosmic time. The constellation becomes a kind of timeline as well as a region of space. When you see a bright star in Leo, you're not seeing it as it existed when that light began its journey to your eyes. This means the depth of Leo can be measured not just in distance, but in time, in the age of the light reaching you. It turns the simple act of stargazing into something like archaeology, uncovering layers of the past preserved in starlight. The deeper you look, the older the images become, creating a stack of different moments all layered together in your view. There's something oddly comforting about this perspective. You don't have to take in the full scale all at once. You can meet the universe in small, manageable pieces. A familiar shape traced against the night sky, a single bright star, a direction that leads your imagination outward into depths you can barely comprehend. The solar neighborhood, that small bubble of space around our sun, containing the few hundred nearest stars, gives us a sense of scale for understanding Leo differently. This neighborhood isn't sharply defined, it's more of a convenience, describing the stars close enough for detailed study. These are our cosmic neighbors, the stars within a few dozen to a few hundred light years that share our general region of the Milky Way. When you compare Leo to this intimate stellar neighborhood, the constellation bridges something profound between the familiar and the infinite, reminding us that even the most distant cosmic structures are still part of the same universe we call home. Picture our sun drifting through space with its stellar neighbors, thousands of other stars scattered around us in what astronomers call the solar neighborhood. This isn't some tightly packed cluster, mind you. These stars are still separated by vast empty distances, but in cosmic terms, they're practically next-door neighbors, all orbiting the galactic center at roughly the same distance, moving through the same spiral arm of the Milky Way. The nearest star to us, Alpha Centauri, sits about 4.25 light-years away. Within 10 light-years of home, you'll find dozens of other stars. Stretch that boundary to 50 light-years, and hundreds more come into view. Push it out to 100 light-years, and thousands of stars populate this loose, three-dimensional cloud that surrounds our sun. This whole region sits inside what's called the local bubble, a patch of space filled with thin, hot gas and relatively little dense dust. That makes it more transparent than many other parts of our galaxy. It's like looking through cleaner air on a clear day versus trying to see through fog. The stars in this neighborhood come in fascinating variety. Red dwarfs dominate the population, small and dim, but incredibly long-lived. Sun-like stars burn steady and reliable for billions of years. Massive, hot stars blaze brilliantly, but burn out fast. White dwarfs sit quietly, the dense, fading remnants of stars that already lived their full lives and collapse down to Earth-sized embers. Now here's where things get interesting. When you look up at the constellation Leo, some of those stars that form the lion's familiar shape are actually part of our local stellar community. Denebula, the star marking the lion's tail, lies just 36 light-years away. Regulus, the bright heart of the lion, sits at about 79 light-years distance. A handful of other Leo stars fall within a couple hundred light-years of home. So when you gaze at Leo on a clear night, you're partly looking at your own galactic neighborhood. Those suns share roughly the same cosmic environment we do, the same background of gas and dust, the same general motion around the galaxy's center. It's a bit like recognizing familiar faces from your own town, scattered among a crowd of strangers. But Leo doesn't stop at the neighborhood boundary. The constellation's depth extends much farther, reaching several hundred light-years for some stars, and beyond them lie distant galaxies sitting far outside the Milky Way entirely. So comparing Leo to the solar neighborhood is like comparing a small, familiar patch of space to a much longer, deeper corridor stretching across the cosmos. Think about this remarkable coincidence of scale. If you imagine our solar neighborhood as a sphere, stretching about 100 light-years in all directions from the Sun, that creates a region 200 light-years across. That's an enormous volume by any everyday measure, containing thousands of individual star systems. Now consider Leo's physical dimensions. Its real width in space of roughly 130 light-years, and its depth extending several hundred light-years for the constellation's most distant stars. Those scales are surprisingly similar. The physical spread of Leo's stars is comparable to the size of the entire region we think of as our local stellar environment. In other words, Leo, as a three-dimensional structure, is about as large as the whole neighborhood of stars around our Sun. From Earth, Leo feels like a piece of the sky, something you can point to and identify. The solar neighborhood feels more abstract, surrounding you but lacking clear boundaries. Yet in physical terms, they occupy similar ranges of space. This overlap helps explain why Leo can feel both familiar and vast simultaneously. You're not looking at some exotic, distant region of the Milky Way. Many of Leo's stars are part of the same general cosmic terrain we inhabit. It suggests the universe isn't divided into sharply separate zones of here and there, but forms more of a continuous landscape with our Sun and Leo stars all drifting through the same broad galactic environment. Our Sun turns out to be fairly ordinary in this context. It's not especially large or small, not particularly bright or dim, compared to its neighbors, just a typical star living a long, steady life among thousands of others in this quiet corner of the galaxy. There's something both humbling and comforting in that ordinariness. When astronomers study nearby stars, they use a technique called parallax, measuring how a star's position appears to shift slightly as Earth moves around the Sun. This method works well within a few hundred light-years, which means many of Leo's stars fall within the same detailed maps we have of our local region. They're part of the same datasets, the same catalogs that describe our stellar neighborhood. But push deeper into Leo's corridor, beyond those few hundred light-years, and the view becomes broader, more statistical. Astronomers must rely on analyzing starlight and brightness to estimate distances. The intimate, detailed picture we have of nearby space gives way to something more abstract, more about general patterns than individual stellar personalities. Scale becomes wonderfully relative in this context. The Milky Way stretches about 100,000 light-years across. Our solar neighborhood, that 200 light-year bubble represents just a tiny fraction of the galaxy's full size. It's like a small town in a vast country. Leo, as a real structure of stars, is roughly the size of that same small town compared to the entire Milky Way. Both the constellation and our local region feel quite small. But compared to each other, Leo suddenly feels impressively large. This shifting perspective reminds us that big and small aren't fixed categories. They depend entirely on what you're comparing things to. A mountain is huge compared to a person, tiny compared to a star. Context shapes perception in profound ways. The local bubble we inhabit formed from ancient supernova explosions that swept away much of the surrounding dust and gas, creating this relatively clear region of space. We're living inside a cosmic cavity carved out by stellar violence millions of years ago. Those long-dead stars, by their explosive deaths, created the transparent environment that now allows us to see deep into space with unusual clarity. Every direction you look from Earth, you'll encounter nearby stars that share our galactic environment. Orion, Ursa Major, Scorpius, and other constellations all include stars from the same local bubble, just scattered in different directions around the sky. So our solar neighborhood isn't something you see in one place. It's something that completely surrounds you. Leo becomes like a window into one portion of that surrounding space. The stars we see aren't actually moving together as a group. Each follows its own independent orbit around the galactic center, like cars on a highway traveling at slightly different speeds. Over millions of years, the patterns we recognize as constellations will gradually distort and reshape as stars drift along their separate paths. The lion we see today looked different to dinosaurs, and will look different to whatever inherits Earth in the distant future. This raises intriguing questions about the nature of cosmic neighborhoods and stellar communities. Are we part of something larger than just gravitational relationships? Do stellar environments create subtle influences we haven't yet discovered? The thin gas that fills the local bubble carries magnetic fields and charged particles. Stars occasionally pass close enough to disturb each other's outer planetary regions. Supernovas send shockwaves racing across interstellar distances. Perhaps we're more connected to our stellar neighbors than we typically imagine. The Milky Way exists as something far more immense than what we typically imagine when we trace familiar patterns in the night sky. This galaxy stretches across roughly 100,000 light-years, forming a flattened disk that contains everything we can see with our naked eyes. The Sun occupies a quiet spot, about halfway out from the galactic center, sitting in one of those long, curving spiral arms that wrap around the galaxy's dense core. When we look up at Leo, we're actually peering from our small position within this vast structure toward another patch of the same cosmic neighborhood. The stars that form the lion's shape belong to the same general region of the Milky Way as our Sun. They're part of nearby spiral arms, sharing the same broad section of this enormous stellar city. But here's where things get interesting. From our earthly perspective, Leo appears as a clean, distinct pattern against the darkness. This clarity exists partly because we're looking away from the densest part of the galaxy, that pale, misty band you sometimes see stretching across the sky. That's the Milky Way's main disk, packed with billions of stars so tightly clustered that their light blurs together into a continuous glow. The concept of neighborhood takes on fascinating dimensions when we consider these scales. On Earth, a neighborhood means close interaction, shared sounds, walkable distances. In space, even our closest stellar neighbors exist light years away. When astronomers talk about our solar neighborhood, they're describing a loose region of stars that happen to drift through the same general area of the galaxy as our Sun. Some of Leo's stars actually belong to this solar neighborhood. They're part of the same local stellar environment that surrounds us. It's a peculiar thought that some points of light in that distant lion pattern are actually cosmic neighbors, sharing our corner of the Milky Way even though they remain impossibly far away by earthly standards. This relationship between Leo and our local stellar region creates an interesting bridge between different scales of astronomy. The constellation includes both nearby stars that we've mapped and studied carefully, and more distant objects that point toward the vast universe beyond our immediate galactic vicinity. Leo becomes a window that spans multiple layers of cosmic distance. The stars in our solar neighborhood aren't fixed in place. They're drifting through space, following long, slow orbits around the galaxy's center. Over millions of years, the composition of our local region changes. New stars drift in, others move away. The same gradual reshuffling affects Leo's pattern. The stars forming the Lion today might not remain part of our solar neighborhood in the distant future. Some could move closer to our region, others might drift farther away. This creates a temporary overlap, a momentary arrangement in the galaxy's long, slow circulation of stars. The connection between Leo and our solar neighborhood represents just one moment in this cosmic dance. Everything participates in a larger movement, even when it appears perfectly still from our brief human timescale. From a planet orbiting one of Leo's stars, if such a world existed, our sun would appear as just another faint point among countless others. It wouldn't stand out, wouldn't be marked as special in any way. The solar neighborhood would look like any other patch of the Milky Way, no more remarkable than anywhere else. This reminds us that concepts like here and there depend entirely on where you happen to be standing. The Milky Way itself represents a fundamentally different kind of structure than a constellation. Our galaxy is a physical system, bound together by gravity, with stars orbiting a common center through shared cosmic architecture. It exists as a real, three-dimensional object regardless of where you observe it from. Leo, by contrast, is pure perspective. It's a pattern that emerges only from Earth's particular position within the galaxy. If you could travel far enough away to see the Milky Way as a whole, then zoom back in on our region, you'd see a wide, gently curving band of stars. Within that band, you'd find a scattering of points that happen to align from Earth's viewpoint into something resembling a lion. From that cosmic vantage point, Leo wouldn't stand out at all. It would blend into the general star field, one small arrangement among countless others. This distinction highlights something profound about how we understand our place in the universe. We're comparing a human-made framework to a natural cosmic structure. The framework isn't meaningless, it just belongs to a different category of existence. One emerges from physics and gravity and a long history of stellar formation. The other emerges from consciousness, pattern recognition, and our need to organize the overwhelming complexity of the night sky. Traveling through the Milky Way would feel like moving through a continuous landscape. There would be no invisible boundaries, no moment when you suddenly left one region and entered another. The galaxy flows together as a unified system. Yet from our fixed position on Earth, we carve this seamless cosmic environment into discrete patterns, separate constellations, distinct regions of sky. Your own position in the universe connects to Leo's stars through this loose but real cosmic kinship. You're part of a planet orbiting a star that drifts through a local region of the galaxy, looking out toward a pattern we call Leo. You share the same broad cosmic environment with those distant points of light, not because you'll ever visit them, but because you're all part of the same galaxy, the same spiral arm, the same long rotation around a distant galactic center. The contrast between scales can feel almost playful. Something as vast as your local corner of the Milky Way gets arranged into a shape you can recognize and remember. A region containing countless stars, spanning dozens of light years, transformed into a simple picture of a lion. It's the universe making itself comprehensible to minds that need patterns, boundaries, familiar forms to navigate the infinite. The constellation Leo occupies a fascinating position when we consider the true structure of our galaxy. Picture this: the stars we see forming the lion shape are scattered across maybe 300 or 400 light-years of space. That sounds enormous, and it is by human standards. But then you realize the Milky Way stretches across 100,000 light-years, from edge to edge. Suddenly Leo becomes something like a neighborhood, tucked away in one small corner of an unimaginably vast cosmic city. This comparison reveals something profound about how we organize reality. We create these boundaries, these names, these patterns in the sky, but space itself doesn't recognize any of it. A spacecraft could drift from what we call Leo directly into the region we've labeled as Virgo, and nothing would change. The same scattered stars, the same drifting gas clouds, the same slow galactic rotation pulling everything along its ancient paths. The universe is seamless, but our minds need segments to make sense of it all. When you look up at Leo tonight, you're actually peering through a relatively clear window in our galaxy. The constellation sits away from the bright band of the Milky Way that arches across darker skies. This positioning means you're looking through a thinner slice of our galactic disk, past fewer foreground stars. That's why astronomers love this region. It offers cleaner views of distant galaxies, millions of light years beyond our own. The Sun sits in a pretty ordinary part of the Milky Way, not at the dense, energetic center, not at the sparse, lonely edges. Just a typical spot along one of the spiral arms. Leo's stars share this same general cosmic neighborhood. So when you trace that familiar pattern, you're not looking at something exotic or far removed from your own galactic address. You're scanning your extended cosmic backyard. But here's where things get beautifully complex. Those spiral arms aren't fixed structures like the spokes of a wheel. They're more like slow waves moving through the galaxy's disk. Stars flow in and out of these arms over hundreds of millions of years, sometimes clustering in the denser regions, sometimes spreading out as they move along. The stars of Leo are part of this grand, unhurried dance. Over deep time, they'll drift through different parts of the galaxy, changing their relationship to those spiral patterns entirely. This movement connects to something both humbling and oddly comforting about timescales. Leo feels permanent when you look up at it, the same reliable pattern your ancestors saw, the same one that will greet you tomorrow night. But the Milky Way rotates, carrying our Sun around the galactic center at about 220 kilometers per second. In the time it takes to complete just one orbit, roughly 225 million years, Leo's shape will have transformed beyond recognition. The galaxy itself contains hundreds of billions of individual stars, each one potentially hosting its own family of planets. Some rocky, some gaseous, some sitting at just the right distance for liquid water to exist on their surfaces. When you're looking at Leo's handful of bright stars, you're seeing a tiny sample from this vast collection of possible worlds. That's not to say Leo is special in harboring life, just that it represents a small piece of an almost incomprehensibly rich cosmic ecosystem. Stepping back even further, the Milky Way belongs to what astronomers call the local group. This includes the great Andromeda galaxy, the smaller Triangulum galaxy, and dozens of dwarf galaxies, all bound together by gravity. They're slowly dancing around each other in patterns that will eventually lead to cosmic mergers billions of years from now. So Leo is a tiny pattern within a medium-sized galaxy, which is itself just one member of a gravitationally bound group, which is part of larger clusters and filaments stretching across the observable universe. But perhaps the most intriguing aspect of comparing Leo to the Milky Way is what it reveals about perception versus physical reality. The constellation spans maybe a few hundred light years of real space, while our galaxy stretches across distances 1,000 times larger. Yet when you look up, Leo can feel like the main event, while the galaxy's faint band seems like mere background lighting. Your attention, not just raw size, determines what feels significant in that moment. This creates an interesting philosophical tension. You exist at human scales, where things are measured in meters and minutes, but you're looking up at a cosmos measured in light years and millions of years. You can trace Leo's familiar shape, something that feels manageable in your mind. Simultaneously, you know this pattern exists within galactic structures so vast that the entire constellation becomes almost insignificant by comparison. Both experiences are real, both are happening at the same time. If you could somehow travel far enough from the Milky Way to see it as a distant spiral, individual stars would vanish into smooth, blended light. Leo would disappear completely. No lion, no pattern, no recognizable shapes at all. Just our galaxy hanging in space, as a single glowing object among countless others. The thought might feel dissolving, but there's something peaceful about imagining all our carefully named patterns rejoining that larger, quieter whole. You don't need to resolve these different scales into one tidy picture. The intimate and the vast can coexist in your mind, each offering its own kind of truth about where you are in the universe. Looking up at Leo stretching across the night sky, there's something almost comforting about how it bridges the gap between what we can grasp and what's truly beyond our reach. This constellation covers roughly 50 degrees of sky, which means you actually have to turn your head to take it all in. That's a considerable chunk of the celestial dome above us. But here's where things get interesting. When we say Leo is big, we're really talking about two completely different kinds of bigness. There's the bigness you see, and the bigness that actually exists out there in space. Your eyes can't tell the difference, but the universe certainly can. The moon and sun appear almost identical in size when you look up at them. Both cover about half a degree of sky. You could block either one with your thumb held at arm's length. Yet the sun is 400 times larger than the moon in actual physical terms. The only reason they look the same size is because the sun happens to be 400 times farther away. It's one of those cosmic coincidences that makes you wonder about the nature of perspective itself. Stars don't have solid surfaces like planets do. Instead, they have fuzzy boundaries where their light production gradually fades away. When astronomers measure a star's size, they're really measuring where that fuzzy edge seems to end. It's like trying to measure the size of a campfire. You have to decide where the flame stops and the darkness begins. Leo's stars are scattered through space at wildly different distances from us. Some are relatively close neighbors, maybe 60 or 70 light years away. Others are much more distant, pushing several hundred light years into the depths of space. So when you trace the outline of the lion in the sky, you're not looking at a flat picture. You're looking through a corridor of space that extends far beyond what your eyes can perceive. The bright star at Leo's heart appears as just one point of light, but it's actually a massive ball of nuclear fire, larger than our entire solar system. Meanwhile, entire galaxies lurk in the background behind Leo's stars, each containing billions of suns, yet appearing as nothing more than faint smudges through powerful telescopes. Physical size becomes a strange concept when applied to constellations. Leo isn't really a thing in the way a planet or star is a thing. It's more like a direction, a way of organizing our view of a particular region of space. The stars that form the lion's mane have no idea they're part of the pattern. They're just going about their stellar business, separated by dozens of light years, connected only by the lines we draw between them in our minds. Galaxies present their own puzzle when it comes to size. The visible part of a galaxy, the bright disk full of stars, might stretch across tens of thousands of light years, but beyond that lies an invisible halo of dark matter that can extend much farther into space. So, depending on what you're measuring, the same galaxy can be considered small or enormous. When you can't walk around something, or touch it, or measure it with your hands, size becomes an abstract concept. On Earth, we understand bigness through our bodies. We feel the size of a room by how many steps it takes to cross it. We sense the height of a tree by how far back we have to lean our heads to see the top. In space, all we have is light arriving at our eyes after traveling for years, decades, or centuries. That light carries information about size, but it's encoded in ways that can fool our intuition. A nearby dim star might look smaller than a distant bright galaxy, even though the star is actually much more massive. Volume adds another layer to this puzzle. Leo occupies a rough three-dimensional region of space, like an invisible cloud of stars spread across several hundred light years. But that volume isn't filled uniformly. It's mostly empty space with a few scattered points of nuclear fire, and the occasional planet or asteroid. The deeper you look into Leo's region of sky, the more you find. Behind the constellation's main stars lie countless more distant stars, then star clusters, then galaxies, then clusters of galaxies, stretching away into the cosmic distance. In that sense, Leo points toward a corridor of space that extends essentially forever, limited only by how far our instruments can see. Star clusters are bound together by gravity, their member stars orbiting around a common center. Galaxies are gravitationally bound systems too, held together by the combined mass of all their stars and dark matter. But constellations aren't bound by anything except human imagination. The stars are just happening to be arranged in a pattern we find meaningful, like finding shapes in clouds. Angular size measures how much of your field of view something occupies. It's the most immediate kind of size you experience when looking at the sky. Linear size measures the actual straight-line distance from one side of an object to the other. For a constellation like Leo, you can estimate linear size by combining its angular width with the average distance to its stars. That gives you a sense of Leo's true width in space, something on the order of 100 light-years or more. But width is just one dimension. Depth is another kind of size, measuring how the constellation stars are spread out along your line of sight. The nearest and farthest stars in Leo are separated by hundreds of light-years of empty space. Planets are relatively simple to measure. They have reasonably well-defined surfaces, so their size usually refers to diameter or radius. Gas giants are a bit trickier, since their atmospheres gradually fade into space, but they still have measurable boundaries where the atmosphere becomes too thin to matter. When astronomers catalogue constellations, they usually list them by area in square degrees rather than physical measurements. Leo ranks among the larger constellations in this sense, covering a significant portion of the celestial sphere. But that doesn't mean it contains more stars than smaller-looking constellations, or that it occupies a larger volume of actual space. The distinction between apparent size and real size matters because our intuitions about scale break down completely when dealing with astronomical objects. A tiny-looking star might be physically enormous compared to a big-looking planet. A faint galaxy might dwarf an entire cluster of bright stars in terms of actual mass and volume. Distance plays tricks with our perception in ways that would be impossible to experience on Earth. If you could somehow travel to one of Leo's more distant stars, the constellation would completely disappear. The familiar pattern would scatter into random points of light, and entirely new patterns would emerge as your perspective shifted through three-dimensional space. The Sun contains more than 99% of all the mass in our solar system, yet it appears the same size as our tiny moon. More than 1 million Earths could fit inside the Sun's volume, but both Sun and Moon can be blocked by your thumb. Scale in astronomy requires constantly translating between what we see and what actually exists. Some of the galaxies visible through Leo are members of gravitationally bound groups, like the famous Leo triplet. These galaxies are engaged in a slow cosmic dance, their mutual gravity gradually pulling them toward an eventual merger billions of years in the future. Yet from our perspective, they appear as static points of light, unchanging from night to night, year to year. The idea that size can be measured in so many different ways suggests something profound about the nature of space itself. Size isn't just a property of objects, it's also a relationship between objects, between a scale of measurement and a thing being measured. In a universe where we can only observe from one small point, every measurement of size becomes an exercise in perspective, a way of reaching across impossible distances to touch something we can never physically encounter. When you look up at a constellation, you're seeing something that covers nearly 1,000 square degrees of sky, which is astronomers' way of measuring how much of the celestial dome gets filled by those stars. But here's where it gets interesting. Size in space isn't just one thing, it's many things all happening at once. The stars themselves might be scattered across a few hundred light-years of actual space, while the corridor they point toward stretches tens of millions of light-years into the distant universe, reaching galaxies so far away they existed in a completely different era. This brings us to something profound about how we measure importance in the cosmos. Mass tells a different story than distance does. A neutron star, barely wider than a city, contains more matter than our entire sun. It's like comparing a marble made of lead to a balloon filled with air. The smaller thing can be far more substantial. When you gaze at those constellation stars, Some have several times the sun's mass packed into their cores, others are lightweight cosmic embers, and behind them all lurk galaxies containing billions upon billions of stars, each with masses that dwarf anything in our local neighborhood. Time adds another layer to this puzzle of cosmic size. Nothing in space stays the same forever. Stars swell into red giants, then collapse into white dwarfs, neutron stars or black holes. Galaxies crash into each other and merge into something new and larger. Even our own sun will balloon outward in the distant future, consuming the inner planets. The Milky Way itself will someday collide with Andromeda, creating a completely different galaxy. So when we talk about how big something is, we're really taking a snapshot of a single moment in a story that spans billions of years. Here's something curious about human perception and cosmic scale. When you spot a constellation in the night sky, you don't think about square degrees or light years or stellar masses. You simply think, there it is, and somehow that pattern fits comfortably in your mind. It occupies a certain amount of space in your awareness, which is its own kind of size measurement. Meanwhile, the entire Milky Way galaxy, vastly larger than any constellation, often feels like background noise, something you barely notice even though it's always there. This reveals something important about attention itself. Size isn't just a property that objects have, it's also a property of focus. Whatever captures your attention grows in significance, while what you ignore shrinks into the background. It's like the universe reshapes itself according to where you point your curiosity. Brightness throws another wrench into our understanding of cosmic dimensions. A star that blazes brightly in your sky might be small but nearby, or enormous but incredibly distant. A dim star could be a massive giant so far away that its light barely reaches you. So when you look at a constellation and see bright stars mixed with faint ones, you're seeing a jumble of different sizes, distances, and energy outputs, all flattened into what looks like a simple picture. All these different ways of measuring size, angular size, physical extent, mass, luminosity, temporal changes, they can all exist simultaneously without contradicting each other. It's like asking how big a mountain is. You could measure its height, its width, its volume, its weight, or how much of the horizon it blocks from your viewpoint. Each answer would be correct and meaningful in its own way. This flexibility of meaning becomes a kind of comfort when dealing with cosmic scales that can otherwise feel overwhelming. If you tried to hold the entire universe in your mind at once, from atoms to galaxy clusters to the edge of observable space, it would be too much to process. Instead, you can start with something manageable. Trace a familiar pattern in the stars, then slowly expand your perspective, adding layers of depth and distance as you feel ready. Now here's where the story takes a fascinating turn. The constellation you know so well only exists because of where you happen to be standing in the galaxy. Change your location in space, and that familiar lion shape would completely dissolve. From a planet orbiting a different star, even one relatively nearby, your sun would be just another faint point of light, easy to miss entirely. The night sky there would be filled with completely unfamiliar patterns. The stars that make up your constellation would be scattered in a totally different arrangement. Some that appear close together from Earth would now be separated by vast distances. Others that seem far apart might appear clustered together. The graceful curve that forms the lion's outline would be broken, its parts drifting across unrelated sections of sky. This means that constellations are fundamentally local phenomena, existing only for observers in a particular region of the galaxy. It's a humbling thought. What feels permanent and universal to you is actually temporary and specific to your cosmic neighborhood. Every planet, orbiting every star, sees its own unique version of the night sky, with its own patterns and arrangements. From some distant stellar systems, the stars you think of as bright landmarks would be invisible, too faint to notice. From others, stars you've never seen would dominate the sky with their brilliance. The entire framework you use to navigate the heavens would be useless anywhere else in the galaxy. Yet there's something beautiful about this cosmic parochialism. The sky above you is uniquely yours in a way that spans not just your lifetime, but the lifetime of your entire species. Every human who has ever looked up has seen essentially the same star patterns because the stars move so slowly that thousands of years pass like moments on their timescale. This gives your local view of the universe a kind of permanence within impermanence. The constellations will eventually change as stars drift through space, but not for many thousands of generations. In the meantime, you share these patterns with every person who has ever wondered about their place in the cosmos, all of you standing together on this small world, looking out at your particular slice of infinity. When you stare up at the night sky, you're witnessing something that's both universal and deeply personal. Every point of light you see exists in a vast three-dimensional space, but your eyes can only capture it as a flat picture projected onto the dome above you. This creates patterns, connections between stars that seem meaningful, but these patterns exist only because of where you happen to be standing in the cosmos. Think about how this works in everyday life. Picture 3 lampposts on a street corner. Walk past them from one direction, and they line up perfectly, creating what looks like a single light source. Move to a different spot, and suddenly they form a triangle. Walk further, and they scatter into what seems like a random arrangement. The lampposts haven't budged an inch. Only your perspective has changed. Now, imagine this same principle, but instead of a few meters between lampposts, we're talking about dozens, even hundreds of light years between stars. The constellation Leo, that majestic line prowling across our spring sky, is made of stars that have no real relationship to each other. Some are relatively close to us, others are incredibly distant. They just happen to line up in a way that creates a recognizable shape when viewed from Earth. But here's where it gets interesting. Move yourself to another star system, just 500 light years away, still well within our own galactic neighborhood, and everything changes. From that new vantage point, the Sun would be just another anonymous star among millions. The patterns we've memorized since childhood would dissolve into chaos. Orion's belt might be bent or broken. The Big Dipper could look like scattered droplets, and Leo, our proud celestial lion, might not resemble anything at all. This reveals something profound about the nature of seeing itself. When we look at stars, we're not just observing distant suns. We're seeing relationships, connections that exist only from our specific location in space. These relationships are intensely local, belonging to our tiny corner of the galaxy. It's remarkable when you think about it, how different human cultures on Earth have seen completely different shapes in the same star patterns. If perspective can vary so much just between different societies on the same planet, imagine how dramatically it would shift across the vastness of space. Let's take a journey through this cosmic perspective shift. Start here on Earth, where Leo clearly resembles a crouching lion. Travel just 10 light years in any direction, a distance that's barely noticeable on galactic scales, and already the closer stars begin to shift against the background of more distant ones. The lion's shape starts to distort slightly. Lines bend, angles change, but the overall pattern remains recognizable. Push out to 50 light years, and the distortion becomes more pronounced. Stars that once formed the lion's outline now appear offset. The majestic curve of the back might flatten, or the proud head might seem to droop. At 100 light years, the pattern largely dissolves. You might still pick out individual stars you remember from Earth's sky, but they no longer tell the story of a lion. They've become just scattered points of light with no apparent connection. This gradual dissolution teaches us something fundamental about the sky itself. It's not a fixed backdrop painted across the heavens. It's a dynamic, ever-changing view that depends entirely on where you're positioned to observe it. What feels large and significant from one location can become small and meaningless from another. Consider what it might be like to stand near the center of our galaxy, in that dense, crowded region where stars are packed together, much more tightly than in our solar neighborhood. The night sky there would blaze with light. Millions of stars would create a background glow so bright that individual constellations might be impossible to pick out. Leo stars would be lost in that crowd, their careful pattern overwhelmed by the sheer abundance of nearby suns. In such an environment, the very concept of connecting stars into shapes might seem absurd. Go the other direction, far above the plane of the galaxy, and you'd see our entire Milky Way stretched out below you like a glowing disk. From that perspective, the stars of Leo would be part of that luminous band, not distinct shapes, set against dark space. The contrast that makes our constellation stand out would vanish completely. Every location in the galaxy creates its own unique sky, its own set of possible patterns, its own potential constellations. A planet orbiting a star in one of the outer spiral arms would see an entirely different arrangement. Beings there would draw their own star pictures, tell their own stories about the shapes they imagined above them. The sun might appear as just another faint star, perhaps too dim to notice without instruments, yet something remains constant through all these perspective shifts. The stars themselves don't change. Regulus continues to be that brilliant, rapidly spinning star at Leo's heart. Denebola keeps shining as a bright, young sun. Algebra maintains its complex dance as a multiple star system. Their fundamental properties remain the same, regardless of where you view them from. Only their apparent relationships shift with your position. This offers a gentle lesson about the difference between appearance and reality. The underlying universe persists, even as our view of it transforms. What we see depends on where we stand, but what actually exists operates by its own rules, independent of our observation point. Time adds another layer to this cosmic perspective game. The stars of Leo are all moving through space, following their own paths around the galactic center. Over thousands and millions of years, their positions relative to each other gradually change. Even if you never move from Earth, the sky itself slowly transforms. The lion we see tonight is not quite the same lion that early humans observed, and it won't be the same lion that future generations will know. From another location in the galaxy, these changes would be even more dramatic. Both space and time work together to reshape the patterns we think we recognize. The constellations we've inherited from ancient cultures are temporary arrangements, brief moments in cosmic history when certain stars happen to line up in ways that spark our imagination. Picture yourself near a star on the far side of the galaxy, tens of thousands of light years from home. From there, our sun would be hidden behind dense clouds of gas and dust. The entire region containing Leo's stars might be too faint or obscured to see with the naked eye. In that sky, Leo wouldn't just look different, it would be invisible entirely. This reminds us that what we see depends not just on geometry, but on what light can actually reach us through the intervening space. Distance, dust, and the brightness of stars all conspire to create the particular view we have from Earth. We could imagine countless other skies, other patterns, other stories written in starlight, but this specific version is ours. There's something both humbling and comforting in that realization. Our experience of the cosmos is simultaneously unique and shared. Unique, because it belongs to our exact position in space and time. Shared, because anyone else in our galactic neighborhood would see something remarkably similar. This creates a kind of cosmic community, beings who might exist on worlds scattered across dozens of light years, but who all look up at roughly the same sky, who might all see the same lion prowling through their spring nights. Throughout human history, we've used these accidental star patterns to navigate, to mark seasons, to tell stories that bind cultures together. The constellations have served as calendars, compasses, and canvases for our myths. But perhaps their greatest gift is this reminder that our view of the universe is both precious and temporary, both meaningful and contingent on where we happen to find ourselves in the vast dance of cosmic space. The patterns we see overhead have served countless purposes throughout human history. People have used these stellar arrangements to find their way across oceans and deserts. They've marked the changing seasons, telling farmers when to plant and when to harvest. Stories have been woven around these points of light, creating mythologies that span generations. All of these uses rely on one fundamental assumption, that the sky remains constant. Night after night, year after year, the same shapes appear in roughly the same places. For human lifespans, this assumption holds true perfectly. The stars seem frozen in their positions, reliable as clockwork, but the universe operates on timescales that dwarf human experience. What appears permanent to us is actually temporary when viewed across millions of years. The constellations we know today are like sketches drawn on a canvas that's slowly shifting and changing. Stars move through space at tremendous speeds, though they're so distant that we can't perceive this motion directly. Over vast periods of time, these stellar wanderings gradually reshape the patterns we've grown familiar with. The lion in the sky won't look like a lion forever. This raises a fascinating question about perspective and place. Imagine standing on a planet orbiting a star in another part of our galaxy. From that distant vantage point, you'd see an entirely different arrangement of bright stars scattered across your night sky. You might connect those stars into shapes that made sense to you, perhaps drawing the outline of creatures familiar to your world. You'd give these patterns names, tell stories about them, use them to navigate. Those constellations would feel just as real and meaningful as any we recognize from Earth. Meanwhile, the patterns we call Leo or Orion would be completely invisible from your distant planet. The stars that form these shapes would be scattered randomly across your sky. If they were visible at all, our familiar constellations would hold no meaning whatsoever. This tells us something profound about the nature of patterns in the cosmos. The galaxy is filled with potential constellations waiting to be discovered. Every possible viewpoint offers its own unique set of stellar arrangements, its own way of organizing the chaos of distant suns into something comprehensible. Size and significance become relative concepts when viewed this way. From Earth, a constellation might span a large portion of the sky, dominating the view and commanding attention. From somewhere else in the galaxy, those same stars might appear small and scattered, hardly worth noticing. What feels important from one perspective can seem trivial from another. The universe doesn't come with built-in significance. We create meaning through our particular viewpoint, our specific location in the cosmic landscape. The sky you see is fundamentally local, a gift of your position in a vast rotating galaxy. It's not universal or absolute. Other worlds see different skies, other arrangements, other possibilities for pattern and story. This doesn't diminish the meaning of what you observe. In fact, it makes these patterns more precious, more personal. They belong specifically to your place in the universe, shaped by the accident of where Earth happens to orbit in relation to distant stars. Consider how this plays out across the rotating Earth itself. As your planet spins through its daily cycle, the constellations appear to rise and set, moving in slow arcs across the sky. But this apparent motion is really your own movement, the Earth carrying you along as it turns. You're not standing still while watching a moving sky. Instead, you're riding on a planet that's spinning at roughly 1,600 kilometers per hour at the equator. Even at higher latitudes, you're still moving at hundreds of kilometers per hour through space. At the same time, Earth orbits the Sun at about 30 kilometers per second. The entire solar system races around the center of the Milky Way at over 200 kilometers per second. All of this motion is wrapped up in the simple experience of looking up and seeing familiar patterns of light. The stars themselves are so tremendously distant that their own movements become invisible against this cosmic dance. They serve as a backdrop, appearing fixed while you spin and orbit and hurtle through the galaxy beneath them. This creates an interesting paradox in our experience of the night sky. The patterns appear stable and permanent, yet they exist only because of constant motion, layers upon layers of movement happening at scales from planetary to galactic. Throughout human history, people have looked up and seen these same arrangements, without necessarily understanding the underlying mechanics. Ancient civilizations traced the same curves of stars and found the same basic shapes we recognize today. For some cultures, these patterns told stories of gods and heroes, epic tales played out across the heavens. For others, they served as practical tools, calendars, written in light that marked important times of the year. Sails used them for navigation, farmers for timing their agricultural cycles. When you look up at familiar constellations, you're participating in this long tradition of human sky watching. You're connecting with countless generations who found meaning in the same points of light, even if their interpretations differed from yours. This connection doesn't require sophisticated understanding of stellar distances or galactic mechanics. It exists at a more fundamental level, in the simple act of recognition, the basic human tendency to find patterns and assign meaning to what we observe. Modern astronomy allows us to hold multiple perspectives simultaneously. You can appreciate both the scientific reality of distant suns and the cultural significance of mythological shapes. These viewpoints don't cancel each other out. They complement and enrich each other. The experience of constellation watching changes dramatically depending on your earthly environment. Under dark skies, far from city lights, stars appear sharp and numerous against a deep black background. Familiar patterns emerge clearly, their outlines easy to trace from bright star to bright star. In urban areas, light pollution washes out many of the fainter stars. The sky takes on a grayish glow rather than true darkness. Constellations become simplified, reduced to only their brightest components. The same patterns exist, but they're harder to see, less complete. This variation in visibility reminds us that our experience of the cosmos depends not just on our position in the galaxy, but on our immediate surroundings here on Earth. The quality of darkness, the clarity of air, even the season of the year all influence what we can observe. Constellations also follow seasonal rhythms, rising earlier or later as Earth moves around its orbit. Some patterns dominate winter skies while remaining invisible during summer months. Others mark the arrival of spring or the transition to autumn. These cyclical appearances have always been meaningful to human cultures. They provide a cosmic calendar, a way of tracking time that connects earthly seasons with celestial events. The same stars that guided ancient peoples through their yearly cycles continue to mark these transitions today. The night sky moves through its own ancient rhythm, marking time in ways that connect us to something much larger than our daily routines. The constellation Leo, the lion, appears in our evening sky during certain months, then slowly fades as Earth continues its orbit around the sun. This celestial dance happens whether we notice it or not, year after year, century after century. As weeks pass, Leo shifts position slightly each night, rising earlier or later, depending on the season. Eventually, it disappears completely, lost in the sun's bright glare during daylight hours. For months it stays hidden, invisible, yet still there. Then gradually, almost secretly, it returns, emerging from the sun's brightness like an old friend coming back home. This repeating cycle creates a kind of cosmic calendar, one that humans have used for thousands of years to mark the passage of time. The stars become more than just points of light. They become anchors in our experience of seasons, of change, of the reliable patterns that shape our world. When you look up at Leo, you're seeing something that connects your brief human life to the vast timescale of the universe. The bright star Regulus, marking the lion's heart, has been shining steadily for millions of years. Its light left the distant stellar surface long before humans walked on Earth. Yet tonight, it reaches your eyes in the same instant you choose to look up. There's something deeply comforting about this reliability. While everything in our daily lives changes constantly, the stars maintain their slow, predictable dance across the sky. Leo will return next year and a year after that, following the same path it has traced for millennia. But here's where the human mind plays a beautiful trick on us. When you lie back and gaze at the constellation, it doesn't feel like you're looking at stars separated by dozens of light years. It doesn't feel like some stars are much closer to us than others. Instead, Leo appears flat, like shapes drawn on the inside of a great dome surrounding Earth. This illusion happens because stellar distances are so enormous that light from these stars reaches us in almost parallel lines. Our vision simply can't detect the subtle differences that would reveal the true three-dimensional structure. So the night sky feels intimate, like a ceiling rather than an endless abyss. Perhaps this is exactly what we need. If we could truly perceive the mind-bending distances involved, the sheer scale might overwhelm us completely. Instead, the stars seem to hover just overhead, close enough to feel personal, familiar, even protective. The star Regulus appears as a single bright point, but it's actually a complex system of multiple stars orbiting each other. These stellar companions are so close together, relatively speaking, that they distort each other's shapes through gravitational forces. Yet from our perspective, this entire cosmic drama appears as one steady light. Other stars in Leo tell their own stories across time. Some are young, hot, and blue-white, burning through their nuclear fuel at tremendous rates. Others are older, cooler, more stable, quietly converting hydrogen to helium in their cores for billions of years. A few are giants, stars that have swollen to enormous sizes as they near the end of their lives. Each star represents a different chapter in stellar evolution, a different answer to the question of how matter and energy interact over cosmic time. Together they form a kind of library, written in light, telling the story of how the universe creates and destroys and creates again. But you don't need to hold all of these facts in your mind at once. The science can settle into the background like distant music, while you simply experience the quiet presence of the constellation above you. The stars will continue their nuclear burning, their gravitational dance, their slow evolution. Whether you think about the details or not, there's something profound about this relationship between knowledge and experience. Understanding the physics doesn't diminish the wonder. It just adds layers of meaning to what you see. The lion becomes both a familiar pattern and a collection of distant suns, both a human story and a cosmic process. Throughout history, different cultures have seen different shapes in these same stars. Some saw a lion, others a sickle, still others entirely different forms. The stars themselves don't care what we call them, but somehow our need to find patterns, to create meaning, transforms random points of light into stories, myths, navigation, aids. This pattern-making ability might be one of humanity's most distinctive traits. We can't help but connect dots, create narratives, find significance in arrangements that exist purely by chance. The stars of Leo have no physical relationship to each other, no shared origin, no common destiny. They just happen to lie in roughly the same direction as seen from Earth. Yet, once we draw those imaginary lines, once we name the lion, something changes in our relationship to that part of the sky. Those stars become more than distant fusion reactors. They become characters in a story, markers in our personal geography of the night. The brightest star, Regulus, sits at the base of a distinctive curve that forms the lion's head and mane. This backwards question mark shape, sometimes called the sickle, is often the first part of Leo that people learn to recognize. Once you see it, you can't unsee it. The pattern becomes permanently etched in your memory. From Regulus, the constellation extends eastward in a triangular pattern, marking the lion's body and hind legs. The star, then Ebola, marks the tip of the tail, completing the celestial creature. These stellar positions have remained virtually unchanged throughout human history, creating a sense of permanence in an otherwise constantly changing world. But even this permanence is an illusion of timescale. Over hundreds of thousands of years, the stars move slowly through space, each following its own path around the galaxy. Eventually, Leo will lose its familiar shape as these stellar motions accumulate. Future humans will see completely different patterns in the same region of sky. This slow transformation connects us to both past and future in unexpected ways. The Leo we see tonight is nearly identical to the one ancient civilizations knew, yet it's also temporary, a brief arrangement in the much longer story of stellar motion through space. When you think about starlight, you're actually looking at time itself stretched across space. The photons hitting your eyes tonight started their journey years, decades, sometimes centuries ago. Each star in Leo, the Lion constellation, sends its light from a different distance. Some of those stellar flames burned bright when your great-grandparents were children. Others began their trek through the void before the American Civil War even started. The star Regulus, Leo's brightest point, sits about 79 light-years away. That means its glow left home around the time World War II was ending. Algeba, another bright spot in the lion's mane, is much farther out, at about 130 light-years. Its light began traveling when photography was just becoming popular, when horses still pulled most carriages through city streets. There's something almost mystical about this cosmic time delay. You're not seeing these stars as they are, but as they were. Each twinkle carries an ancient message, a photon that has traveled through the emptiness between worlds, just to reach your retina. In a sense, astronomy is really archaeology, digging through layers of time instead of layers of Earth. Leo itself moves across our sky in a predictable pattern. During spring evenings in the northern hemisphere, the lion climbs high overhead. By summer, it's already starting to sink toward the western horizon. This happens because Earth orbits the Sun, changing our nighttime view as the months pass. It's like being on a slow carnival ride, rotating around a central fire while the cosmic scenery shifts around us. The ancient Greeks saw this same pattern of stars and imagined a great lion. But step back further in time, and the constellation looked different. Stars have their own motion through space, called proper motion. Over thousands of years, they drift apart, change positions, rearrange themselves into new patterns. The Leo we see today is just one frame in a very long movie. Stellar motion reveals something fascinating about our galaxy structure. The Milky Way isn't a solid disk, it's more like a loose spiral of star groups, all orbiting around a central black hole. Every star, including our Sun, follows its own elliptical path around this galactic center. The journey takes about 200 million years to complete. Since Earth formed, we've made this cosmic orbit roughly 20 times. During each galactic year, our solar system passes through different regions of space. Sometimes we're in the sparse areas between spiral arms, where stars spread far apart. Other times we cross through denser regions, where stellar nurseries birth new suns from clouds of gas and dust. These changes affect the night sky, our planet experiences, over geological time. Leo contains several double star systems, pairs of stars locked in gravitational dance around each other. Algeba, which appears as a single golden point to the naked eye, actually consists of two giant stars orbiting every 500 years or so. They're so close together from our perspective that only telescopes can split them apart into separate lights. Binary stars like these teach us about stellar evolution, how stars age and die. When two stars share an orbit, they can exchange material, especially if one grows into a red giant phase. Gas streams from the larger star to its companion, sometimes triggering spectacular explosions called novae. These cosmic fireworks can briefly outshine entire galaxies. The space between stars isn't truly empty. Interstellar medium, mostly hydrogen gas with traces of heavier elements, fills the apparent void. This thin material came from stars that died long ago, their outer layers blown into space during their final moments. When new stars form, they incorporate these recycled elements. In this way, stellar death feeds stellar birth, an endless cycle of cosmic renewal. Looking at Leo on a clear night connects you to this vast recycling program. The calcium in your bones, the iron in your blood, the oxygen you breathe, all came from stellar furnaces that burned billions of years ago. You're made of star stuff, literally built from atoms forged in nuclear fires and scattered across space when those ancient suns died. This realization shifts your perspective on existence itself. You're not separate from the universe, you're part of it, a temporary arrangement of cosmic material that happens to be conscious. Your awareness is the universe looking at itself, a brief moment when scattered stardust organizes into thoughts and feelings and wonder. The lion stars continue their ancient paths whether anyone watches or not. They burned before life existed on Earth, and they'll likely shine long after our species becomes extinct. Yet here you are, in this fleeting instant, able to see them and understand something of what they are. That intersection of cosmic time and human consciousness creates a kind of meaning that doesn't need grand explanations or religious frameworks. Light pollution hides many stars from modern eyes, but Leo remains visible even from most cities. Its main pattern cuts through the sky like a cosmic question mark, or maybe a backwards question mark, depending on how your imagination connects the dots. Finding it becomes easier with practice, like recognizing a familiar face in a crowd. The constellation marking system humans invented helps us navigate this stellar landscape, but it's entirely artificial. Stars don't actually cluster into lions or bears or hunters. These patterns exist only in human perception, stories we tell to make sense of the overwhelming complexity above us. Other cultures saw completely different pictures in the same arrangements of lights. Aboriginal Australians looked at this region of sky and saw a wedge-tailed eagle. Hindu astronomy placed a horse there. Chinese stargazers mapped it as part of a great dragon. Each culture projected its own symbols onto the neutral canvas of distant suns. The stars themselves remain unchanged by our interpretations, indifferent to our need for narrative and meaning. Yet these stories serve a purpose beyond mere entertainment. They encode practical information about seasons, navigation, timekeeping. Before clocks and calendars, the night sky served as humanity's first computer, storing data in memorable patterns. Leo's position told farmers when to plant crops, helped sailors find their way across oceans. Modern astronomy has moved beyond constellation stories, but it hasn't eliminated wonder. We now know that stars form in nebulae, vast clouds of gas and dust that collapse under their own gravity. We understand fusion reactions in stellar cores, how hydrogen becomes helium and releases the energy that makes stars shine. Knowledge deepens mystery rather than destroying it. Each star in Leo has its own story, its own timeline, its own eventual fate. Some will expand into red giants before shrinking into white dwarfs. Others might explode as supernovae, briefly outshining entire galaxies. A few could collapse into black holes, regions where gravity becomes so strong that not even light escapes. These stellar destinies play out over millions or billions of years, timescales that dwarf human history. Yet in this moment, their combined light creates a recognizable pattern overhead, a celestial landmark that has guided human imagination for thousands of generations. Tomorrow night, they'll be there again. Shifted slightly by Earth's rotation, but essentially unchanged from your perspective. That stability offers a kind of comfort in an uncertain world. Political systems rise and fall, technologies transform daily life, personal relationships change and evolve. But the lion stars maintain their positions, reliable beacons in an otherwise chaotic existence. They remind us that some things endure beyond human timescales, that the universe operates according to patterns larger than our immediate concerns.